The Big Bang did not bang. There was no sound. No explosion rippling through space like some cosmic fireworks show. No debris scattering across a celestial canvas. Nothing to hear, nothing to witness, nothing to mark the supposed moment when everything began. And yet, here you are, reading these words, breathing air that was forged in the hearts of dying stars, standing on a planet that orbits a rather ordinary sun in the outer reaches of a galaxy containing hundreds of billions of other stars, in a universe that stretches so far beyond your comprehension that the light from its edges will never, ever reach your eyes. You exist. Reality exists. But have you ever stopped, truly stopped, to ask yourself why? Not how. We'll get to the how. But why is there something rather than nothing? Why does existence exist at all? Why aren't you just not here? Why isn't everything just not there? It's the kind of question that makes your mind stumble. That makes you pause and restart the thought because it feels too big, too strange, too impossible to hold in your consciousness. And that discomfort you feel right now, that slight vertigo in your thoughts, that's your brain confronting something it was never designed to confront. You evolved to find food, avoid predators, navigate social hierarchies. You did not evolve to understand why reality has the audacity to exist in the first place. But here's what's truly unsettling. The more we've learned about the universe, the more impossible our existence becomes. Every discovery in physics, every breakthrough in cosmology, every new understanding of the fundamental forces that govern reality, they all point to the same disturbing conclusion. We shouldn't be here. The universe shouldn't be here. The odds against existence are so staggeringly, incomprehensibly vast that the fact you're experiencing this moment right now is nothing short of a cosmic miracle, or a cosmic accident, or something far stranger than either. Let me show you what I mean. You think you understand the beginning of the universe, don't you? You've heard the story. 13.8 billion years ago, everything that exists, all the matter, all the energy, all the space itself, emerged from an infinitely small, infinitely hot, infinitely dense point, a singularity, and then it exploded outward in the Big Bang. And here we are, simple, clean, scientific. Except that story is a lie, not because it's wrong, exactly, but because every word in that description is misleading in ways that fundamentally distort what actually happened. There was no explosion. There was no outward. There was no small point, because there was no space for that point to occupy. There was no moment before because time itself didn't exist. And calling it a singularity is just a polite way of saying we have absolutely no idea what happened there. Because all of our physics breaks down into mathematical gibberish. You want to know what really happened at the beginning of the universe? Nobody knows. I don't mean we have a few competing theories we're working out. I mean, the very question might be meaningless. Asking what happened before the Big Bang might be like asking what's north of the North Pole. The question seems to make sense until you realize it doesn't. Time might not extend backwards forever. Space might not extend outward forever. Reality itself might not be what you think it is. And the origin of existence might be so fundamentally different from anything your human brain can conceive that we're not even asking the right questions yet. But let's start with what we do know, or what we think we know, or what we've convinced ourselves we know, because the alternative is too disturbing to accept. Right now, as you exist in this moment, you are living in an expanding universe. Galaxies are racing away from each other at staggering speeds. The space between them is growing. If you could watch the cosmos in fast forward, you'd see a universe spreading out like ink dropped in water, everything flowing away from everything else. The distances between galaxy clusters increasing with every passing second. Now run that film backward. Rewind time. Watch those galaxies rushing toward each other instead of apart. Watch the universe shrinking, compressing, everything getting closer, denser, hotter. Keep rewinding, faster. The universe is now half its current size, a quarter, a thousandth, a millionth. Keep going. The atoms that make up your body, the stars, the galaxies, they're all converging on a single point. Time is running backward toward some ultimate moment when everything existed in the same place, at the same instant. And then what? Then our mathematics shatters like glass. At that moment, the moment we call the Big Bang, though it was neither big nor a bang, our equations produce infinities. Infinite density, infinite temperature, infinite curvature of space-time. And in physics, infinities aren't profound. They're not meaningful. They're not poetic. They're wrong. They're a sign that your theory has failed, that you've reached the edge of what your models can describe, that you've entered a realm where the rules you thought governed reality simply don't apply anymore. Think about that. The most successful, most tested, most accurate scientific theories we've ever developed, general relativity and quantum mechanics, both fail at the exact moment we need them most. At the origin of existence itself, our best understanding of reality collapses into mathematical nonsense. So here's the first thing you need to understand. We don't know how the universe began. We can trace its evolution backward to a fraction of a second after the supposed beginning. We can describe what happened when the universe was a trillionth of a second old, when it was smaller than an atom, when it was so hot that matter as we know it couldn't exist. But that first moment, that transition from non-existence to existence, that remains hidden behind a wall we cannot penetrate. It's called the Planck era. The first 10⁻43 seconds of the universe. That's a decimal point followed by 42 zeros and then a 1. A span of time so brief that light itself could only travel a distance of 10⁻35 meters, about 20 orders of magnitude smaller than a proton. During this infinitesimal instant, the universe was so dense, so hot, so extreme, that quantum effects would have dominated gravity. Space and time themselves would have been subject to quantum uncertainty. Reality itself would have been blurred, probabilistic, undefined in ways that make no intuitive sense whatsoever. And we have no tested theory that describes what happened then. Think about what that means. The single most important event in all of existence, the event that led to you being here right now, reading these words, wondering about your origins, is completely outside our understanding. We're standing at the edge of a cliff, staring into darkness, trying to describe what lies at the bottom without being able to see it, measure it, or test our ideas about it. But it gets stranger, because even if we can't describe the first instant, we can ask deeper questions, and those questions lead to even more disturbing places. If the Big Bang was the beginning of space and time, what do we even mean by beginning? A beginning implies a transition, from one state to another, from nothing to something. But if time itself began at the Big Bang, then there was no before, no moment preceding it, no prior state from which the universe emerged. How can something begin? If there's no before for it to begin from, This is where language fails us, where intuition fails us, where every mental model you've ever built about cause and effect simply disintegrates. You think you understand causation. You've experienced it your entire life. Events happen in sequence. Causes precede effects. One thing leads to another. It's the foundation of how you navigate reality. But at the origin of the universe, causation itself might be an illusion, an emergent property that only makes sense once time already exists. So asking, what caused the Big Bang, might be asking a meaningless question. It's like asking, what does purple taste like? The words are arranged properly, the grammar is correct, but the question itself is incoherent because it's mixing categories that don't belong together. Unless, of course, time didn't begin at the Big Bang. Unless there was something before, something prior, something from which our universe emerged. And oh, there are theories, endless theories, each one more exotic than the last. Maybe our universe is just one bubble in an infinite cosmic foam, where new universes are constantly being born from quantum fluctuations in some higher dimensional space. Maybe the Big Bang was actually a big bounce, the latest in an infinite series of expansions and contractions, where universes are born, expand, collapse, and then rebound into new universes, over and over, forever. Maybe our universe budded off from a parent universe through a black hole. Maybe it's a computer simulation running in some vast meta-reality we can't access. Maybe it spontaneously fluctuated into existence from nothing at all, because quantum mechanics allows particles to pop into existence for brief moments. So why not entire universes? Each theory sounds like science fiction. Each one seems more absurd than the last, and yet each is taken seriously by physicists. Because the alternative, that we simply can't answer these questions, is somehow less satisfying than proposing universes bubbling into existence from nothing. But let's focus on that last idea for a moment. The idea that the universe came from nothing, from literal absolute nothingness. Because if you think that sounds simple, you haven't thought about it carefully enough. What is nothing? You probably imagine empty space, a void, a blank expanse of blackness stretching in all directions. But that's not nothing. That's something. That's space. Space is a thing. It has properties. It can expand. It can curve. It can ripple with gravitational waves. It's a physical entity described by general relativity. So try again. Imagine nothing. No space, no time, no laws of physics, no quantum fields, no potential for anything, no mathematical structures, no logical truths, just nothing. Can you picture it? You can't. And neither can I. Because the moment you try to imagine nothing, you're imagining something. Even the concept of nothing is something. It's an idea, a mental construct. And if there truly was nothing, no space, no time, no laws, no potential, no anything, then there would be no rule preventing something from existing. But there would also be no mechanism allowing something to exist. No framework for existence to emerge from. How do you get from absolute nothing to something? You can't, because getting from implies a transition, which implies time, which means time already exists, which means you're not starting from nothing anymore. This is the paradox at the heart of existence. If there was ever truly nothing, there should still be nothing. Because nothing has no properties, no mechanisms, no potential to become something. But if there was always something, then what is that something? Why does it exist? What gives it the right to be real rather than imaginary? What separates the actually real from the merely possible? You're starting to feel it now, aren't you? That slight dizziness, That sense that the ground is falling away beneath your feet. Because every answer leads to another question. Every solution reveals a deeper mystery. And the more you think about existence, the more impossible it becomes. Here's something that should disturb you. The universe is comprehensible. The fact that we can do physics at all is strange beyond measure. There are mathematical equations that describe how reality behaves. Clean, elegant, precise equations that work. That make predictions. That allow us to understand the universe. Why? Why should the universe be mathematical? Why should it follow rules? Why should it be possible for creatures made of star stuff to develop brains capable of understanding the very laws that govern their existence? There's no obvious reason why reality should be intelligible to minds at all. It could have been pure chaos, pure randomness, an incomprehensible soup of events with no patterns, no structure, no discoverable order. But it's not. Reality has a structure, a deep mathematical structure, and that structure is so precisely calibrated, so finely tuned, that if you changed almost any of the fundamental constants of physics by even a tiny amount, the universe would be unable to support complexity, unable to form stars, unable to forge the heavy elements needed for life, unable to produce anything remotely like you. This is the fine-tuning problem, and it's absolutely haunting. Consider the strong nuclear force, the force that binds protons and neutrons together in atomic nuclei. If it were just 2% weaker, atomic nuclei beyond hydrogen couldn't form. No carbon, no oxygen, no elements necessary for chemistry, for planets, for life. The universe would be nothing but hydrogen and helium. Forever. But if the strong force were just 2% stronger, all the hydrogen would have fused into helium in the early universe. No hydrogen means no water. No long-lived stars like our sun. No stable chemistry. Just a universe of helium and heavier elements, equally lifeless. 2%. That's the margin. That's how precisely calibrated this one force had to be for you to exist. And it's not just the strong force. It's the electromagnetic force, the weak nuclear force, the strength of gravity, the mass of the electron, the mass of the quarks, the cosmological constant, the mysterious energy causing the universe to expand. Each one of these values had to fall within an incredibly narrow range for the universe to be capable of producing anything interesting at all. Change the electron mass by a small amount, and chemistry doesn't work. Atoms can't bond properly. Change the mass of the down quark relative to the up quark, and neutrons become unstable in ways that prevent the formation of complex nuclei. Increase the cosmological constant by a small factor, and the universe expands so rapidly that galaxies never form. Decrease it too much, and the universe collapses back on itself before stars can ignite. The list goes on and on, parameter after parameter, all fine-tuned to spectacular precision. Some estimates suggest that if you changed the cosmological constant by 1 part in 10^120, that's a 1 followed. By 120 zeros, the universe would be uninhabitable. How do you explain that? There are only a few options, and none of them is satisfying. Option 1. We're incredibly lucky. We won the cosmic lottery. Out of all the possible ways the fundamental constants could have been set, they just happened to land on values that allow for complexity and life. Pure chance, nothing more. But this explanation feels hollow. It's not that unlikely events can't happen. They happen all the time. It's that this particular event is so spectacularly unlikely that calling it luck seems more like giving up than explaining anything. Option 2. The universe was designed. Something or someone set the constants to their current values deliberately. The universe was created with the specific intention of producing complexity, or life, or observers capable of asking these questions. This is the territory of theology and philosophy, not physics. It doesn't answer the question so much as push it back one level. If the universe was designed, what designed the designer? And if you're willing to accept that a designer can exist without explanation, why not just accept that the universe can exist without explanation? You haven't solved the mystery. You've just renamed it. Option 3. There are many universes, perhaps infinitely many, each with different values for the fundamental constants. Most of them are sterile, lifeless, unable to support anything interesting. But given enough universes, some of them, by pure statistical necessity, will have constants that allow for complexity. And we find ourselves in one of those universes not because it's special, but because we couldn't exist anywhere else. It's a selection effect. We're observing the universe we're in precisely because it's the kind of universe that can produce observers. This is the Multiverse Hypothesis. And while it sounds like wild speculation, it emerges naturally from several different areas of physics. Inflation theory, our best model for the early universe, suggests that our observable universe might be just one bubble in an infinite foam of expanding regions. String theory, a candidate for a unified theory of physics, predicts a vast landscape of possible universes with different configurations. Quantum mechanics, in some interpretations, suggests that reality is constantly branching into multiple versions every time a quantum measurement occurs. The multiverse isn't proven, but it's not idle speculation either. It's a serious hypothesis being explored by serious physicists, and if it's true, then the fine-tuning problem dissolves. Of course we find ourselves in a life-permitting universe. We couldn't exist anywhere else. But does that really satisfy you? Because even if the multiverse is real, even if there are infinite universes with every possible combination of physical laws, you're still left with the deepest question of all. Why is there a multiverse? Why does anything exist at all? Why are there rules? Any rules? Even if those rules vary from universe to universe. Why is there something rather than nothing? You can push the question back as far as you want. You can invoke multiverses, quantum fluctuations, eternal inflation, higher dimensions, mathematical structures existing independently of physical reality. But eventually, you hit the same wall. At some point, something exists without explanation. Something is just there, without a prior cause, without a reason, without an answer to the question, why? Either the chain of causation goes back infinitely, an infinite regress of causes, causing causes, causing causes, with no ultimate origin, or it terminates in something that exists for no reason, something that just is, because it is. Both options feel wrong. Both violate our intuitions about how reality should work, and yet one of them must be true, unless the question itself is flawed, unless we're asking the wrong thing entirely. What if existence isn't something that needs to be explained? What if the universe doesn't require a cause because causation is a feature within the universe, not a constraint on the universe itself? What if reality is self-explaining, not in the sense that we understand the explanation, but in the sense that its existence is somehow necessary, inevitable, unavoidable? Some physicists and philosophers have suggested that mathematical truths exist necessarily, that 2 plus 2 equals 4, not because someone decided it should, but because it couldn't be any other way. Mathematical relationships are true in all possible worlds, in all possible configurations of reality, even in the absence of any physical universe at all. And if mathematics exists necessarily, and if the physical universe is ultimately a mathematical structure, then perhaps reality itself exists necessarily. Perhaps the universe is real because the mathematics that describes it cannot not exist. This is the Mathematical Universe Hypothesis, proposed by cosmologist Max Tegmark. The idea that physical reality is literally made of mathematics, that particles, forces, space, and time are all manifestations of mathematical structures. And since mathematical truths exist necessarily, reality itself exists necessarily. The universe isn't described by math. It is math. It's a beautiful idea, almost elegant, but it raises as many questions as it answers. Why these mathematical structures and not others? Why is our universe described by the specific equations of quantum field theory and general relativity rather than some other set of mathematical relationships? And even if mathematical structures exist necessarily, why should they correspond to anything physical? Why should any mathematical structure be instantiated as a real, tangible universe that people can actually experience? You're seeing the pattern now. Every answer spawns new questions. Every explanation reveals deeper mysteries. It's almost as if the universe is designed to resist ultimate understanding, as if there's a horizon of comprehension we can approach, but never cross. Or maybe we're just asking the wrong questions because we're using the wrong concepts. Maybe terms like existence, causation, beginning, and nothing are crude approximations, useful for navigating everyday life, but fundamentally inadequate for grasping the deep nature of reality. Maybe the origin of existence is so radically different from anything we can imagine that our language doesn't have words for it, our mathematics doesn't have equations for it, and our minds don't have concepts for it. Consider quantum mechanics. At the quantum level, reality behaves in ways that violate every intuition you've ever had. Particles exist in multiple states simultaneously until observed. Objects can be entangled across vast distances, connected in ways that seem to defy the speed of light limit. Particles can tunnel through barriers they shouldn't be able to cross. The act of measurement affects the outcome of experiments in ways that suggest reality itself is observer-dependent. None of this makes sense if you think of reality as a collection of objects, existing in definite states at definite locations. But quantum mechanics isn't wrong. It's the most precisely tested theory in all of science. Its predictions match experimental results to an absurd degree of accuracy. And yet, a century after its development, physicists still argue about what it means, about what's really happening at the quantum level, about whether particles have definite properties before measurement, whether the wave function represents something real or just our knowledge, whether reality splits into multiple branches or collapses into a single outcome. We can use quantum mechanics to build computers, lasers, and transistors. We can exploit it for technology, but we still don't understand what it's telling us about the nature of reality. We have the equations. We can make predictions, but we don't know what any of it means, and if we don't understand the reality we can observe and measure and test, how can we possibly understand the origin of reality itself? How can we comprehend the transition from non-existence to existence when we can't even agree on what constitutes existence at the quantum level? Here's what keeps me awake at night. the possibility that existence is a brute fact, that there is no explanation, that at the bottom of all our questioning, beneath all our theories and hypotheses and philosophical speculations, there is simply the raw, inexplicable reality that something exists rather than nothing, and there is no why, no reason, no ultimate cause, just existence, asserting itself, being real, for no reason at all. That feels unsatisfying. It feels like giving up, like declaring defeat in the face of the ultimate question. But maybe that's the human condition. Maybe we're creatures who evolved to find patterns, to seek causes, to build explanations, confronting a universe that has no obligation to make sense to us. Maybe the origin of reality is simply beyond our cognitive horizons. Maybe we're like ants trying to understand quantum field theory. The concepts required are so far beyond our mental architecture that we literally cannot think them. Or maybe not. Maybe we're on the verge of a breakthrough. Maybe some young physicist working right now will develop a theory that explains everything. A theory that unifies quantum mechanics and general relativity. A theory that describes the Planck era. A theory that tells us what happened at the beginning. How something came from nothing. Why the constants are fine-tuned. Whether the multiverse is real and what existence itself actually means. But even if that happens, even if we develop a theory of everything that answers every question about the physical universe, we'll still be left with one final irreducible mystery. Why does anything exist at all? Why this universe and not another? Why any universe instead of none? Why is there a reality to be described by theories in the first place? And perhaps that question has no answer. Perhaps it's simply the wrong question. Perhaps existence is its own explanation, requiring no justification beyond itself. Or perhaps the answer is something so strange, so counterintuitive, so alien to human thought, that when we finally discover it, we won't recognize it as an answer at all. You came here expecting explanations. You wanted to know how reality came to exist. And what I've given you instead is a catalog of mysteries. A list of everything we don't know. A tour through the places where our understanding fails and our intuitions collapse. But here's the thing. That's not a failure of science. That's the frontier of science. That's where the real questions live. Not in the answers we've already found, but in the mysteries we're still chasing. In the places where we don't know what's happening, where our theories break down, where the universe refuses to conform to our expectations. And the greatest mystery of all, the one that dwarfs every other question in cosmology, physics and philosophy, is the simple, devastating fact that you exist, that I exist, that there is something rather than nothing. That reality decided to be real. The Big Bang did not bang, but something happened, something impossible, something that our best theories can't fully explain, something that transformed a state of non-existence, or something so unlike our universe that we can't even call it existence, into the vast, complex, beautiful cosmos you inhabit right now. 13.8 billion years later, matter that was forged in the cores of ancient stars has arranged itself into a pattern complex enough to wonder about its own origins, to ask questions it might never be able to answer, to stare into the darkness at the edge of knowledge and feel wonder instead of fear. That's where you are right now, standing on a planet that circles a star in a galaxy that's rushing through space, asking questions that might have no answers, seeking explanations for mysteries that might be unexplainable. And the most beautiful thing? You don't have to understand it to be part of it. You don't need to know why existence exists to experience the fact that it does. You are here. You are real. You are a piece of the universe that became conscious enough to ask about itself. That's not an answer, but maybe it's enough. Maybe the question itself, the fact that reality produced creatures capable of wondering why reality exists, is the only answer we're going to get. Maybe the universe doesn't owe us an explanation. Maybe existence simply is, and our job isn't to explain it, but to witness it, to experience it, to be amazed by it. But we're not going to stop asking. That's not who we are. We're the species that looked at the night sky and asked what those lights were. That developed mathematics to describe the motion of planets. That split atoms to understand matter. That built telescopes to see the edge of the observable universe. That won't stop asking questions just because those questions might not have answers. So let's go deeper. Let's examine what we do know. Let's trace the story of the universe from that first incomprehensible instant to the present moment. Let's explore the theories, the evidence, the breakthrough discoveries that have brought us to this edge of understanding. Let's look at the cosmic microwave background, the accelerating expansion, the formation of galaxies and stars, the origin of complexity, the emergence of life. Let's examine how reality came to exist, not because we'll find a complete answer, but because the search itself is what makes us human. Because wondering about existence is what we do. Because somewhere in the asking, in the exploring, in the relentless pursuit of deeper understanding, we find meaning. Even if the ultimate question remains forever out of reach. Let's start with something you think you understand. The universe is expanding. You've heard this countless times. Galaxies are moving away from each other. Space itself is stretching. The universe grows larger with each passing second. Edwin Hubble discovered this in 1929, measuring the redshift of distant galaxies and realizing they're all receding from us. The further away a galaxy is, the faster it appears to be moving. This relationship, now called Hubble's law, was the first concrete evidence that the universe is not static, not eternal and unchanging, but dynamic and evolving. Simple enough, the universe is getting bigger. But bigger than what? Think about that question. When you inflate a balloon, it expands into the room around it. The rubber stretches, yes, but it's expanding into something, into air, into space that already existed. But the universe isn't expanding into anything. There is no outside, no pre-existing space for the universe to grow into. Space itself is what's expanding. This is where your intuition starts to fail you. You want to picture the universe as a thing within a larger container, growing to fill that container. But that's wrong. The universe is the container. It's everything that exists. When it expands, it's not moving into anything. It's creating more space between the things that already exist within it. Imagine you're an ant on the surface of that balloon. You can only perceive the two-dimensional surface. You can't see up or down into the third dimension. As the balloon inflates, you notice other ants getting farther away from you. Every ant, no matter which one you ask, sees all the other ants moving away. There's no center to this expansion on the surface. Every point is equally valid. Every ant can claim to be stationary while everything else moves. This is our situation. We observe galaxies receding in all directions, and we might be tempted to think we're at the center of expansion. But we're not. An observer in any other galaxy would see exactly the same thing. Everything moving away from them. The expansion has no center because it's not an expansion into space. It's an expansion of space. Now, here's where it gets genuinely strange. If you could somehow stop the expansion, freeze the universe in place, how big would it be? What's the total volume of space? We don't know. We can't know. We can only observe what's called the observable universe, the region from which light has had time to reach us since the Big Bang. That's a sphere about 93 billion light-years across, not 13.8 billion, which you might expect given the universe's age, because space has been expanding while that light traveled. The objects that emitted the light we're seeing now are much farther away than they were when the light began its journey. But beyond that observable horizon, we have no idea. The universe could be just slightly larger than what we can see. It could be infinite. Both possibilities are consistent with observations. An infinite universe doesn't mean it goes on forever in time. It can be infinitely large spatially, while still having a finite age. At the moment of the Big Bang, an infinite universe would have been infinitely dense everywhere. At every point, matter and energy were compressed to infinite density. Not concentrated at one point, but at all points simultaneously. Does that make sense? It shouldn't. Infinity doesn't behave intuitively. An infinite universe at the Big Bang wasn't smaller than it is now in terms of extent. It was infinite then, too. But the distance between any 2 points was smaller. Infinite space, but compressed. It's a mathematical concept that breaks our spatial reasoning. Perhaps the universe is finite, but unbounded, like the surface of a sphere. You could travel in one direction forever and eventually return to your starting point without ever encountering an edge. Einstein's general relativity allows for this. Curved space that wraps back on itself. The universe could be a four-dimensional hypersphere, impossible to visualize but mathematically precise. Or perhaps space is flat, extending infinitely in all directions, and what we observe is merely one patch of an endless expanse. The cosmic microwave background suggests the universe is remarkably flat, to within measurement precision. But flat doesn't necessarily mean infinite. A flat sheet can still have boundaries. We simply don't know which geometry describes the whole of reality. This uncertainty isn't a failure of science. It's an honest acknowledgement of limitation. We can only work with what we can observe. And the observable universe, vast as it is, might be an infinitesimal fraction of the total. Most of reality could be forever beyond our reach, not because our instruments aren't good enough, but because light hasn't had time to traverse those distances. And in an accelerating expansion, which is what we observe, regions beyond our current horizon are receding faster than light can catch up. We're causally disconnected from them. They can't affect us, we can't affect them, and we'll never see them. The universe is hiding most of itself from us. We're trapped in a cosmic island, surrounded by an ocean we can never cross. Let's examine what we can see. The cosmic microwave background, that ancient light released when the universe became transparent, tells us remarkable things. It's uniform to extraordinary precision. Look at the sky in any direction, measure the temperature of that background radiation, and you'll get nearly identical values. 2.7 Kelvin, just above absolute zero. Variations exist, but they're tiny. A few parts in 100,000. This uniformity is called the horizon problem, and it's deeply puzzling. For regions of space to have the same temperature, they need to have been in thermal equilibrium, energy needed to flow between them, equalizing temperatures. But regions of the cosmic microwave background that are on opposite sides of the sky, separated by billions of light years, were never in contact. Light hasn't had enough time since the Big Bang to travel between them. They couldn't have equalized their temperatures because they couldn't have interacted, and yet they have the same temperature. How? It's as if you placed ice cubes in different rooms of a mansion, rooms with no connecting passages, and later discovered they'd all melted at exactly the same rate despite having no way to exchange heat. The uniformity implies coordination, but the laws of physics forbid that coordination. Cause and effect require information to travel, and information can't travel faster than light. So how did distant regions of the early universe coordinate to have identical properties? Inflation provides an answer, but it's an answer that feels like cheating. Before the universe was even a second old, in fact, in the first tiny fraction of a second, space underwent exponential expansion. It doubled in size, then doubled again, then doubled again, perhaps 100 times or more in less time than it takes light to cross an atom. This inflationary period was so rapid, so violent, that causally connected regions were stretched to cosmic scales. Imagine a smooth marble, perfectly uniform. Now, stretch it to the size of a galaxy while maintaining its proportions. The surface would appear perfectly smooth at any scale you examine because you're looking at what was once a tiny, uniform region. Inflation does this to space itself. Regions that were in thermal equilibrium, small enough to have equalized their properties, were blown up to sizes larger than the entire observable universe. So what we see, that uniform cosmic microwave background, is actually a tiny patch of space that was in equilibrium before being stretched. This solves the horizon problem elegantly. Too elegantly, some would argue. Inflation requires a new field, the inflaton, with very specific properties. It needs to turn on, drive exponential expansion, then turn off, converting its energy into the particles and radiation that filled the early universe. We don't know what the inflaton is. We don't know why it has the properties it needs to have. We've essentially solved one mystery by postulating another. But inflation also makes predictions. It predicts the spectrum of fluctuations we should see in the cosmic microwave background. It predicts the universe should be flat, or very nearly so. It predicts gravitational waves from the inflationary period itself, ripples in space-time that should be detectable in the polarization of the cosmic microwave background. Some of these predictions have been confirmed with stunning precision. The flatness of the universe, the spectrum of fluctuations, inflation nailed them. Other predictions remain unconfirmed. The primordial gravitational waves are elusive. Experiments like BICEP 2 thought they'd detected them in 2014, but the signal turned out to be contamination from dust in our galaxy. The search continues. If those gravitational waves are found, it would be powerful evidence that inflation really happened. If they're never found despite increasingly sensitive searches, inflation might need to be replaced or refined. Science proceeds through this dialectic, theory and observation in conversation, each constraining the other. We propose mechanisms to explain observations, then look for additional consequences of those mechanisms. Sometimes we find them, strengthening our confidence. Sometimes we don't, sending theorists back to their blackboards. The early universe wasn't just hot. It was a furnace where time itself was still learning to move. At Planck temperature 10 to the 32 Kelvin, particles and forces unified. There was no distinction between electromagnetism and the weak nuclear force, perhaps no distinction between those and the strong force, possibly no distinction between anything at all. The universe existed in a state of perfect symmetry, undifferentiated potential. As it expanded and cooled, symmetries broke. Forces separated. particles acquired distinct identities. The Higgs field, permeating all of space, gave mass to fundamental particles. Without that field, without that symmetry breaking, electrons and quarks would be massless, traveling at the speed of light, never forming atoms, never building the complexity that leads to stars and planets and you. The Higgs field is another of those concepts that sounds like theoretical invention but was spectacularly confirmed when the Large Hadron Collider detected the Higgs boson in 2012. The field exists. It does what theory predicts. And its discovery was a triumph of human ingenuity. Billions of dollars, thousands of scientists, decades of work to find a particle that exists for a fraction of a second before decaying, proving that a field permeating all reality gives everything mass. But why does the Higgs field exist? Why does it have the specific properties it has? These questions remain. We've discovered the mechanism, but not the reason. It's like finding the gears inside a watch and understanding how they mesh, but not knowing why someone built a watch in the first place. The descent from the Big Bang through various temperature regimes is a story of increasing complexity. At first, the universe was so hot that even protons and neutrons couldn't exist. Quarks and gluons formed a plasma, a quark-gluon soup, too energetic for particles to bind. As temperatures dropped below 1 trillion Kelvin, quarks combined into protons and neutrons. These nucleons then underwent nucleosynthesis, fusion reactions producing the first atomic nuclei, mostly hydrogen, some helium, traces of lithium, the lightest elements forged in the first 3 minutes of cosmic history. Everything heavier, carbon, oxygen, iron, gold, came later, manufactured in stars. But the basic recipe was set in those first minutes. The ratio of hydrogen to helium, the abundance of deuterium, the trace amounts of lithium-7, all of these were determined by the density and temperature of the early universe. And we can measure these abundances today, billions of years later, and they match the predictions of Big Bang nucleosynthesis with astonishing precision. This is one of the strongest pieces of evidence for the hot Big Bang model. Multiple independent observations, the expansion of the universe, the cosmic microwave background, the abundance of light elements, all point to the same history. The universe was once much hotter, denser, and smaller. The evidence isn't circumstantial, it's overwhelming. And yet, the Big Bang theory itself is silent on the most important question. What banged? What existed at time zero? What caused the initial conditions? The theory describes evolution from a hot, dense state. It doesn't explain the origin of that state. It's like having a detailed account of a forest fire's spread, the temperature gradients, the fuel consumption, the atmospheric conditions, but no explanation of what sparked the initial flame. We understand the process, but not the ignition. General relativity, taken to its logical extreme, points to a singularity. A point where density becomes infinite, where space-time curvature becomes infinite, where the equations themselves break down and produce meaningless results. Physicists don't believe in actual infinities. When a theory produces infinities, it's signaling its own limitations. It's saying, beyond this point, I cannot guide you. Quantum mechanics should step in here. At Planck scales, lengths of 10 to the negative 35 meters, times of 10 to the negative 44 seconds, quantum effects dominate. Space-time itself should fluctuate, foaming with quantum uncertainty. Virtual black holes wink in and out of existence. The smooth fabric of spacetime Einstein described becomes a chaotic quantum sea. But we don't have a working theory of quantum gravity. We have candidates, string theory, loop quantum gravity, others. But none are confirmed, and they make different predictions about the universe's earliest moments. String theory suggests the universe has additional dimensions beyond the 3 spatial dimensions we experience. 6 or 7 extra dimensions, curled up so small we don't notice them. These extra dimensions might have played a role in the universe's birth, providing mechanisms for tunneling from nothing to something, from one quantum state to another. Loop quantum gravity suggests space-time itself is quantized, made of discrete units like atoms of space. Instead of a singularity at the Big Bang, there would be a quantum bounce, a minimum volume that space can compress to before rebounding. The Big Bang wasn't a beginning, but a transition, a bridge from a prior contracting phase to our current expanding phase. These are speculations, beautiful mathematical structures that might describe reality or might be elegant failures until we can test them. And testing quantum gravity theories is extraordinarily difficult. They remain in a limbo between physics and metaphysics. What we do know is that the universe is not just made of the matter we can see. Observations of galaxy rotation, gravitational lensing, and the cosmic microwave background all indicate that most of the universe's mass is invisible. Dark matter, they call it. Not dark because it's black, but dark because it doesn't interact with light at all. It doesn't emit, absorb, or reflect electromagnetic radiation. It's transparent, intangible, passing through ordinary matter like ghosts through walls. We know dark matter exists because we can see its gravitational effects. Galaxies rotate too fast for the visible matter they contain. Stars should be flung into space by centrifugal force, but they're not. Something invisible is providing additional gravity, holding galaxies together. Clusters of galaxies do the same thing, exhibiting more gravitational mass than can be accounted for by stars and gas. The cosmic microwave background also reveals dark matter's presence. The pattern of fluctuations depends on the ratio of ordinary matter to dark matter, and observations pin down that ratio precisely. About 5 parts ordinary matter to 27 parts dark matter. Dark matter outweighs ordinary matter 5 to 1. Everything you can see, every star, every planet, every galaxy, is a minority component of the universe. Most of reality is invisible. What is dark matter? We don't know. It could be undiscovered particles, WIMPs, weakly interacting massive particles, perhaps left over from the Big Bang. It could be axions, hypothetical particles predicted by particle physics but never detected. It could be primordial black holes, formed in the early universe, too small to detect individually, but collectively providing the necessary mass. Experiments deep underground, shielded from cosmic rays, wait for dark matter particles to occasionally interact with detector material. So far, nothing definitive. The mystery deepens when we consider dark energy. Not only is most matter invisible, but something is causing the universe's expansion to accelerate. Gravity should slow expansion. The mutual attraction between all matter should decelerate the universe's growth. But in 1998, observations of distant supernovae revealed the opposite. The universe's expansion rate is increasing. Something is pushing space apart, overwhelming gravity's attractive pull. This something has been called dark energy, another placeholder name for a phenomenon we observe but don't understand. Dark energy constitutes about 68% of the universe's total energy density. Dark matter is 27%. Ordinary matter, everything we can see, touch, measure directly, is 5%. We understand, at best, 5% of what the universe contains. This should be humbling. We've sent probes to the edges of the solar system, split atoms, mapped genomes, built computers that exceed human cognitive abilities in narrow domains. And yet, 95% of the cosmos consists of substances we can't identify. We're like ancient cartographers who've mapped the coastline, but labeled the interior, "Here be dragons." Except in this case, the dragons are real, and we're living among them. Mostly unaware, dark energy might be the cosmological constant, a term Einstein introduced and later called his greatest blunder. The cosmological constant represents vacuum energy, the energy inherent in empty space itself. Quantum field theory predicts that even empty space contains energy from virtual particle-antiparticle pairs constantly appearing and disappearing. This vacuum energy would act as a repulsive force, causing space to expand. The problem is that when you calculate the expected vacuum energy from quantum field theory, you get a number that's 10 to the 120th times larger than what we observe. This is the worst prediction in the history of physics. Something is catastrophically wrong with our understanding. Either quantum field theory's prediction is wrong, or there's some unknown mechanism canceling out almost all the vacuum energy. Or dark energy isn't vacuum energy at all, but something else entirely. Alternative explanations exist. Quintessence, a dynamic field that changes over time. Modified gravity theories where general relativity breaks down at cosmic scales. Parallel universes leaking energy into ours. None of these are as simple as the cosmological constant, and simplicity is usually a guide to truth in physics. But the cosmological constant comes with that monstrous prediction mismatch. So perhaps simplicity is misleading us. The acceleration of expansion has profound implications for the universe's future. If dark energy remains constant, galaxies outside our local group will eventually recede beyond our cosmic horizon. In trillions of years, future observers will see a universe that appears to contain only their local galaxy cluster. The cosmic microwave background will have redshifted into undetectability. All evidence for the Big Bang, for cosmic expansion, for the existence of anything beyond their local region, will vanish. They'll inhabit an apparently static, isolated universe, unaware of the vast cosmos beyond their reach. This is called the Big Rip scenario, or heat death, or the long cold. Variations on a theme of entropy increase, complexity decrease, and ultimate dissipation. Stars will burn out. Black holes will evaporate through Hawking radiation. Eventually, even protons might decay if certain grand unified theories are correct. The universe approaches a state of maximum entropy, uniform distribution of energy, nothing happening because nothing can happen. Thermal equilibrium means death of process, death of change, death of time itself in any meaningful sense. But this fate is trillions of years away. For now, the universe is young, vibrant, full of stars being born, and galaxies colliding, and black holes devouring matter, and potentially civilizations asking the same questions we're asking. We exist in a brief, precious window when complexity is possible, when structure exists, when the universe is old enough to have formed heavy elements, but young enough that stars still shine. Consider the improbability of your existence in this context. For you to exist, the universe needed specific properties. Matter had to clump into galaxies. Stars had to form and die, seeding space with heavy elements. Planets had to accrete from protoplanetary disks. On at least one planet, chemistry had to bootstrap itself into biology. Life had to evolve complexity, develop multicellular structures, survive mass extinctions, eventually produce consciousness, intelligence, civilization, technology. Any break in this chain, and you don't exist. If the universe were slightly different, if the strong nuclear force were a few % weaker, stars couldn't fuse hydrogen. If electromagnetism were slightly different, chemistry wouldn't work. If dark energy dominated earlier, galaxies wouldn't have had time to form. The universe appears calibrated for complexity, and this calibration is both remarkable and disturbing. The fine-tuning problem refuses to go away. Physicists can calculate what would happen if various fundamental constants had different values. In the vast majority of cases, the resulting universe is sterile. No stars, or stars that burn out immediately. No chemistry, or chemistry too simple to build complex molecules. No planets, no life, no observers. Out of an infinite space of possible universes, we inhabit one of the vanishingly rare ones capable of supporting complexity. This demands explanation. Either we're extraordinarily lucky, we won a cosmic lottery with odds of 1 in 10 to the 100th power, or worse. Or something selected for these values. A designer? A multiverse where all possibilities exist, and we necessarily find ourselves in a hospitable one. Or some principle we haven't discovered that makes these values inevitable. None of these options is satisfying. Luck seems inadequate for such extreme fine-tuning. Design invites questions about the designer's origin. The multiverse is possibly untestable. An unknown principle is just renaming our ignorance. And yet, one of these must be true, or some fourth option we haven't conceived. The universe refuses to yield its secrets easily. Every answer raises new questions. Every discovery reveals new mysteries. The cosmic microwave background is uniform. But why? Inflation explains it. But what caused inflation? Quantum fluctuations. But why does the quantum field exist? It's turtles all the way down. Except even that metaphor assumes there's a bottom to reach. Perhaps there is no bottom. Perhaps reality is self-contained, requiring no external explanation. The universe exists because it must, because non-existence is incoherent, because something is the only stable state, and nothing is inherently unstable. This is called the Leibnizian cosmological principle, and it has a certain appealing quality. It eliminates the need for a first cause by arguing that existence itself is logically necessary. But it's not clear that existence is logically necessary. You can imagine, or think you can imagine, absolute nothingness. No matter, no energy, no space, no time, no laws, no possibilities. The null set. Pure absence. And if nothingness is imaginable, it's not logically contradictory, which means existence isn't logically necessary, unless nothingness is actually impossible. Unless the concept contains hidden contradictions. Some philosophers argue exactly this. They claim that absolute nothing is incoherent because even the framework for discussing nothing, logic itself, is something. The rules of logic exist, therefore nothingness never truly obtains. Reality might be the set of all logically consistent structures, and empty nothingness isn't among them. These arguments blur the line between physics and philosophy until the distinction becomes meaningless. At the foundations of existence, everything becomes philosophical Because we're asking questions about the preconditions for physics itself. Why are there laws? Why is there mathematics? Why does logic work? These aren't questions physics can answer because physics assumes them as axioms. Stand outside on that clear night again. Look up at those stars, those time machines showing you the past. Realize that the light hitting your eyes has traveled through expanding space, red-shifted by cosmic expansion, carrying information about events that occurred when the universe was younger. Every observation is historical. Even looking at your hand involves light that left your skin nanoseconds ago. You can't perceive the present, only the past, because information needs time to travel. And the further you look, the further back you see. The sun as it was 8 minutes ago. The nearest star as it was 4 years ago. The Andromeda Galaxy as it was 2.5 million years ago. The edge of the observable universe as it was 13.8 billion years ago, shortly after the Big Bang. We're looking back through time, watching cosmic history unfold in reverse. The universe is its own museum, displaying its past for anyone with instruments sensitive enough to observe. And what we see is a story of evolution from simplicity to complexity, from uniformity to structure, from a featureless plasma to the rich tapestry of galaxies and stars and planets we observe today. But we're missing chapters. The first stars, population 3 stars made only of hydrogen and helium, have never been directly observed. They should have formed a few 100 million years after the Big Bang, massive and short-lived, dying in supernova explosions that seeded the cosmos with heavier elements. We see the products of those explosions, the enriched gas that formed later stars, but the population 3 stars themselves are too distant, too faint, or already long dead. The James Webb Space Telescope might find them, peering deeper into the universe's past than ever before. But as of now, they remain theoretical necessities inferred from other observations. The formation of the first galaxies is also murky. How did structure emerge from the smooth early universe? Dark matter plays a crucial role. Its gravity pulled gas into overdense regions, creating wells where normal matter could accumulate. But the detailed process, the exact timeline, the full zoo of galaxy types, and how they evolved, these are active areas of research with many open questions. Supermassive black holes present another puzzle. We observe quasars, incredibly luminous objects powered by black holes billions of times the sun's mass, from when the universe was less than 1 billion years old. How did black holes grow so massive so quickly? Stellar mass black holes form from dying stars, but even with aggressive accretion and mergers, it's difficult to explain supermassive black holes appearing so early. Perhaps they formed directly from dense regions in the early universe, bypassing the stellar stage. Perhaps they grew faster than we think possible. Perhaps we're missing something fundamental about black hole formation or growth. Black holes themselves are regions where general relativity predicts singularities, points where density becomes infinite and space-time curvature becomes infinite. But as with the Big Bang singularity, physicists don't believe these infinities are real. They indicate where our theory breaks down. Inside a black hole's event horizon, beyond the point where escape becomes impossible, space-time geometry becomes extreme. Falling toward the singularity, you'd experience tidal forces stretching you vertically while compressing you horizontally. Spaghettification, in the delightful terminology physicists employ. But what you'd encounter at the very center, Whether there's truly a point of infinite density or some quantum structure we don't yet understand remains speculative. Hawking radiation adds another layer of strangeness. Quantum effects near the event horizon cause black holes to emit radiation and slowly evaporate. Small black holes evaporate faster than large ones. Given enough time, immensely long times, far exceeding the current age of the universe, even supermassive black holes will evaporate into nothing, or nearly nothing. The final moments of evaporation are unclear. Does the black hole leave behind a remnant? Does it explode? Does it quantum tunnel into a white hole, ejecting its information into another region of space-time? Information preservation is at stake here. Quantum mechanics insists that information can't be destroyed. The evolution of quantum states is reversible, in principle, but black holes appear to destroy information, consuming it behind the event horizon and then evaporating away. This creates the black hole information paradox, unresolved despite decades of work by the brightest minds in theoretical physics. Proposed solutions involve holography, the idea that information about a region's interior is encoded on its boundary, like a hologram encoding three-dimensional information on a two-dimensional surface. If true, this suggests reality itself might be holographic, with the three-dimensional space we experience emerging from information encoded on a distant two-dimensional boundary. These ideas push physics into metaphysical territory. Is space-time fundamental or emergent? Are we living in a projection, a shadow cast by deeper realities we can't directly perceive? The mathematics suggests these aren't idle speculations, but serious possibilities with concrete consequences. Returning to the Big Bang, if the universe has no edge in space, then where does it begin in time? General relativity suggests a beginning, a singular moment when time itself started. But quantum mechanics suggests that time might be emergent too, not fundamental, but arising from more basic quantum processes. Some theories propose that the Big Bang wasn't a beginning but a transition, a phase change, a boundary between two regimes where our concepts of before and after lose meaning. Wheeler's quantum foam suggests space-time at Planck scales is a seething chaos where causality breaks down. If this is true, asking what happened before the Big Bang is like asking what's inside an electron. The question assumes structure that doesn't exist. At small enough scales, space and time might not be continuous but discrete, quantized, and are classical. Notions of causality and temporal sequence might be approximations that work at large scales but fail at the foundations. This would resolve the beginning problem not by providing an explanation but by dissolving the question. There is no before because before presupposes classical time, and classical time only emerges above Planck scales. At the Big Bang, space-time is quantum, and quantum space-time doesn't have a clear temporal structure. The universe didn't begin, it simply is, has always been, in a timeless quantum sense that defies narrative description. Human language evolved to describe medium-sized objects moving at moderate speeds in three spatial dimensions. We have no intuitive vocabulary for quantum superposition, for space-time foam, for 10-dimensional string theory landscapes. When physicists describe these concepts, they're using mathematics because mathematics can handle abstractions language can't. But this creates a gap between understanding and comprehension. You can understand the mathematics without comprehending the reality it describes. You can manipulate equations without visualizing what they represent. This is where metaphor and analogy become essential. The rubber sheet bending under a bowling ball to represent gravitational curvature, the ant on a balloon to represent cosmic expansion, the coin toss to represent quantum superposition. These are all lies, useful lies that convey partial truth. The universe doesn't care about our cognitive limitations. It operates according to principles that might be fundamentally alien to human intuition. We're trying to understand quantum gravity with brains that evolved to throw spears and gather berries. And yet, we're succeeding. Partially, imperfectly, but genuinely. We can predict the cosmic microwave background spectrum. We can detect gravitational waves. We can measure the universe's expansion rate. We can test quantum mechanics to extraordinary precision. We're not flailing in total darkness. We have light, even if it illuminates only a small region of a vast unknown. The journey from the Big Bang to now is 13.8 billion years of cosmic evolution. Inflation, nucleosynthesis, recombination, dark ages, first stars, first galaxies, structure formation, star birth and death in multiple generations, planets forming, chemistry complexifying, life emerging at least once, consciousness arising at least here. This happened. The evidence is overwhelming. The chain of events from hot, dense state to you reading these words is well established, even if individual links need refinement. But the origin that remains wrapped in mystery. And perhaps it must remain so. Perhaps the universe's ultimate origin is beyond physics, beyond observation, beyond proof or disproof. Perhaps we're asking questions reality wasn't designed to answer. Or perhaps the answer is there, waiting, encoded in phenomena we haven't yet discovered or measurements we haven't yet made. Perhaps quantum gravity will reveal it. Perhaps the multiverse will explain it. Perhaps something we can't currently imagine will illuminate it. What's certain is that the cosmic setup, the stage on which existence plays out, is far stranger than common sense suggests. Space expands. Time began. Invisible matter dominates. Dark energy accelerates expansion. Black holes warp space-time to breaking points. The universe was once plasma, then became transparent, and will eventually become cold and dark. These aren't metaphors. This is reality, as best we can determine it. And underlying all of it, making everything possible, are laws, mathematical structures that govern behavior, that make prediction possible, that turn chaos into cosmos. Where those laws came from, why they have the form they do, whether they could have been different. These questions probe the boundary between physics and metaphysics, between what can be known and what might be forever mysterious. The cosmic setup raises as many questions as it answers, and that might be exactly what we should expect at the frontier of human knowledge. Imagine reality as a film reel, not a film being projected, the actual physical strip of celluloid, every frame already existing simultaneously. The past isn't gone. The future isn't yet to come. They're all there, laid out in sequence, each moment as real as the present. You're not moving through time. Your consciousness is moving along the reel, illuminating one frame after another, creating the illusion of flow, of change, of becoming. This is called the block universe, and it emerges naturally from Einstein's special relativity. When Einstein unified space and time into spacetime, he didn't just create an elegant mathematical structure. He fundamentally altered what it means for something to exist. In classical physics, there's a universal now, a cosmic present moment that everyone shares. But relativity destroyed this notion. There is no universal now. Simultaneity is relative. Events that are simultaneous for one observer occur in sequence for another, moving at different velocity. If simultaneity is relative, then the distinction between past, present, and future becomes observer-dependent. What's now for you might be yesterday or tomorrow for someone else, depending on their motion. But if their yesterday exists for them now, then it must still exist in some sense. If their tomorrow is now for them, then your future must already exist somewhere in space-time. The conclusion is startling. All moments in time exist equally. The past hasn't ceased to exist. The future is already there, waiting for your consciousness to reach it. Einstein himself recognized the implications. In a letter consoling the family of his lifelong friend Michel Bessot, he wrote, "For those of us who believe in physics, the distinction between past, present, and future is only a stubbornly persistent illusion." This wasn't poetic license. This was Einstein taking his own theories seriously. But if the future already exists, what happens to free will? Your choices tomorrow are already made, already exist as fixed events in space-time. You're not choosing, you're discovering choices that were always there, encoded in the block universe's structure. Every decision you think you're making freely has already been made. Every word you'll speak, every thought you'll have, every emotion you'll feel, all of it exists now, frozen in the space-time manifold, waiting only for your subjective experience to catch up. This is called eternalism, and it's philosophically disturbing. It suggests you're not an agent but a passenger, riding along predetermined rails, unable to alter anything because alteration requires a present that can be different from what it is. But the present is fixed as the past, as unchangeable as yesterday. You're a four-dimensional object, a world line stretching from birth to death, and your consciousness is merely reading along that world line, frame by frame, under the illusion that it's creating what it's actually discovering. The alternative is presentism. Only the present moment exists. The past has ceased to be. The future hasn't begun. Reality is a moving point, a cosmic now that sweeps forward, creating existence as it goes. This preserves free will and matches our subjective experience, but it conflicts with relativity. If only the present exists and simultaneity is relative, then what exists is observer-dependent. Reality becomes subjective, which seems untenable for a physical theory. There's a third option, possibilism. The past and present exist, but the future is genuinely open, not yet determined. This tries to preserve both the fixed nature of what has occurred and the freedom of what's to come. But it faces its own problems. Where exactly is the boundary between determined past and open future? How does reality transition from possibility to actuality? What mechanism closes off quantum superpositions and makes definite what was indefinite? These aren't idle philosophical musings. They directly impact how we understand the Big Bang. If the block universe is correct, the Big Bang isn't something that happened 13.8 billion years ago. It's still happening, exists now, as real and present as this moment. Time is an illusion. Everything, the entire history of the cosmos, exists eternally in a frozen four-dimensional structure. The beginning of the universe isn't an event in the past, but a boundary condition on space-time, an edge where the manifold terminates. And at that edge, space-time curves back on itself, becoming undefined, producing what mathematicians call a singularity. Not a thing, but a breakdown. a point where the equations fail, where physical quantities become infinite, where prediction becomes impossible. Singularities haunt physics. They appear not just at the Big Bang, but inside black holes. At the center of rotating solutions to Einstein's equations, anywhere gravity becomes extreme enough to curve space-time infinitely. General relativity predicts them, but general relativity also breaks down at them. It's self-limiting, pointing to its own failure. Roger Penrose proved in the 1960s that singularities are inevitable in general relativity, given certain reasonable conditions. If you have enough matter in a small enough region, collapse to a singularity is unavoidable. There's no escape, no way to prevent it. The geometry of space-time itself forces everything toward infinite density. This was disturbing to many physicists, who hoped singularities were mathematical artifacts that would disappear with more careful analysis. Penrose showed their fundamental features of the theory. Stephen Hawking extended this work, proving that the universe itself must have emerged from a singularity if general relativity holds, and the universe is expanding. Running time backward, everything converges toward a point of infinite density. The Big Bang singularity isn't something we can choose to avoid by clever initial conditions. It's forced on us by the mathematics. But neither Penrose nor Hawking believed the singularities were real. They believed quantum effects would become important before infinity was reached, that quantum gravity would resolve the singularities into something finite and comprehensible. The problem is, we don't have quantum gravity yet. We have the prediction of singularities and no confirmed theory to eliminate them. What is a singularity, really? The word suggests a point, but that's misleading. A singularity isn't a place in space-time. It's a boundary, an edge, a terminus. Space-time ends there, not in space, but in its own structure. It's not that there's something at the singularity we can't understand. It's that there's no there. Space-time itself ceases, and asking what's beyond is like asking what's north of the North Pole. Except quantum mechanics suggests this might not be the end of the story. At Planck scales, 10 to the negative 35 meters, 10 to the negative 44 seconds, quantum fluctuations should dominate. Space and time stop being smooth and become granular, foamy, uncertain. The singularity might be replaced by a quantum bounce, a minimum volume, a transition region where classical concepts fail, but quantum concepts take over. Loop quantum gravity. One approach to quantum gravity does exactly this. It quantizes space itself, making it discrete rather than continuous, just as energy comes in quanta. Photons, discrete packets, space comes in minimum units. You can't subdivide space infinitely. There's a smallest possible volume, beyond which the concept of smaller becomes meaningless. In loop quantum gravity, the Big Bang singularity is replaced by a big bounce. The universe didn't begin, it transitioned from a prior contracting phase. As that earlier universe collapsed, quantum effects became important before a singularity could form. Instead of crushing to infinite density, space bounced, beginning a new expanding phase. Our universe is the rebound from a previous universe's collapse. This is elegant. It eliminates the singularity and the question of ultimate origin by making the universe eternal through cyclical transformations. But it raises new questions. Was there a first cycle, or have cycles continued infinitely into the past? If infinite cycles, we're back to the problem of infinite regress. No ultimate origin, just cycles all the way down. If a finite number of cycles, what started them? We've pushed the origin problem back, but not eliminated it. String theory offers different possibilities. In string theory, fundamental particles aren't point-like, but tiny vibrating strings. Different vibration modes correspond to different particles. An electron is one vibration pattern, a quark another, a photon another. This resolves certain infinities in quantum field theory because strings have extent, not zero size, and this extent smooths out interactions that would otherwise be singular. String theory requires extra dimensions, not just the 3 spatial dimensions we experience, but 6 or 7 more, compactified, curled up so small that we don't notice them. These extra dimensions aren't optional window dressing. They're mathematically necessary for the theory's consistency. If they don't exist, string theory doesn't work. But we've never detected them, and it's not clear we ever could at accessible energies. In string theory's landscape, there might be 10 to the 500 different possible vacuum states, different ways the extra dimensions can curl up, each producing different physical laws, different constants, different particle properties. If this is true, our universe with its specific laws is one possibility among an inconceivably vast number. Most of those possibilities are sterile, unable to support complexity. We observe this particular set of laws because we couldn't exist in most of the others. This brings us to the multiverse, but not the quantum many-worlds interpretation yet. This is the string landscape multiverse, where different regions of space settle into different vacuum states. Each region is effectively a separate universe with different physics. Eternal inflation can produce this naturally, as space expands exponentially. Different regions undergo quantum fluctuations that leave them in different vacuum states. The inflating space becomes a patchwork of bubble universes, each with different properties. If this is correct, asking why our universe has the laws it does is like asking why you were born in this particular city. It's not that this city is special or that your birth location was predetermined by fundamental principles. It's just where you happen to be born. And if you'd been born elsewhere, you'd be asking the same question there. The laws of physics aren't universal. They're local, specific to our bubble, and other bubbles have different laws. This feels like giving up on fundamental explanation. Instead of explaining why physics is the way it is, we're saying it's random, contingent, one possibility among many. Some physicists hate this. It seems like defeat, like abandoning the quest for deep understanding in favor of anthropic reasoning. Others embrace it as the natural conclusion of our best theories. If string theory and inflation both lead to a multiverse, perhaps we should accept it. But there's another multiverse, stranger and more controversial, the many worlds interpretation of quantum mechanics. Quantum mechanics is the most successful theory in physics. Its predictions match experiments to extraordinary precision. 1 part in a trillion for some quantities. And yet nobody knows what it means. Nobody knows what actually happens when a quantum system is measured. When Schrödinger's wave function collapses from multiple possibilities to a single outcome. The standard Copenhagen interpretation says the wave function collapse is real. Before measurement, the particle exists in superposition, multiple states simultaneously. Measurement forces it into one state. The act of observation changes reality. But what counts as measurement? Does it require consciousness? A detector? Any interaction? Where's the boundary between quantum and classical? The Copenhagen interpretation doesn't say. It works instrumentally. It tells you how to calculate, but it doesn't explain what's happening. In 1957, Hugh Everett proposed a radical alternative. Nothing collapses. The wave function never reduces to a single outcome. Instead, every possible outcome occurs, but in different branches of reality. When you measure a quantum system, you don't force it into one state. You become entangled with it, and the universe splits. In one branch, you see outcome A. In another branch, you see outcome B. Both branches are equally real. Both versions of you exist, each having observed different results, each believing their outcome is the only one. This is the many worlds interpretation, and it's philosophically shocking. It says every quantum event splits reality into multiple branches. Every decision you make, every particle interaction, every moment, all of them generate countless branching universes. The number of branches is staggering, beyond calculation, beyond comprehension. An infinity of infinities, each containing a complete history, a complete you, experiencing different outcomes. The appeal is that it takes quantum mechanics at face value. The Schrödinger equation describes how quantum states evolve, and in many worlds, that evolution is all there is. No collapse, no special role for measurement, no mysterious boundary between quantum and classical. Everything is quantum, always. And what we perceive as collapse is actually decoherence. Our quantum state becoming entangled with the environment in ways that make different branches effectively separate. The cost is ontological extravagance. You're not just saying the universe is big. You're saying there are infinitely many universes, constantly multiplying, most of them nearly identical to ours, but with tiny variations in quantum outcomes. Every time an electron's spin is measured, the universe branches. Every photon that hits your retina, every neuron that fires in your brain, every particle interaction in your body, all generating new branches, new realities, new versions of you experiencing different things. Does this explain anything? Critics argue it doesn't. You've traded one mystery, wave function collapse, for another. Why do we experience one branch and not the others? In many worlds, you do experience all branches, but each version of you only has access to their branch's history. You can't communicate across branches, can't verify the others exist, can't test the hypothesis. It's metaphysics masquerading as physics. Defenders counter that many worlds is the simplest interpretation. It takes the Schrödinger equation seriously without adding extra postulates about collapse. Occam's razor favors the theory with fewest assumptions, and many worlds has only one. Quantum mechanics is universal. Everything else follows. The apparent extravagance, infinite universes, isn't an added assumption, but a consequence of taking quantum mechanics literally. And there's evidence, sort of. Quantum interference depends on multiple paths contributing to outcomes. In the double-slit experiment, a particle goes through both slits simultaneously, interfering with itself. In many worlds, it actually does go through both slits, one version through each, in different branches. And these branches remain coherent long enough to interfere before decohering into separate realities. The interference pattern we observe is a shadow of many worlds, a trace of branches that split and briefly remained entangled. Whether this constitutes evidence or reinterpretation is debated. What's clear is that quantum mechanics forces us into uncomfortable positions. Either measurement is special and causes collapse, but then we need to explain what measurement is and why it has such power. Or measurement isn't special and everything exists in superposition, but then we need to explain why we experience definite outcomes. Or there's some other interpretation: pilot wave theory, quantum Bayesianism, objective collapse models, each with its own philosophical baggage. The relevance to the Big Bang is this: if many worlds is correct, the universe didn't begin in one state. It began in superposition, all possible initial conditions simultaneously. The Big Bang was a quantum event, and quantum events generate branches. Our universe, the one we observe with its specific properties, is one branch among countless others. Different branches have different initial quantum fluctuations, different random outcomes in the early universe, leading to different large-scale structures, different galaxies, different histories. This version of the multiverse is more fundamental than the string landscape multiverse. It's not about different regions of space with different physics. It's about different quantum branches of the same space with the same physics, but different random outcomes. And if quantum mechanics is universal, if it applies to the universe as a whole, then this multiverse is inevitable. Every quantum event in the universe's history generates branches, and the number grows without bound. Imagine standing at the Big Bang, watching the wave function of the universe evolve. It's not a single trajectory, but a superposition of all possible trajectories. In some branches, quantum fluctuations during inflation produce slightly more structure. In others, slightly less. In some, dark energy is slightly stronger. In others, slightly weaker. Each branch is a full universe, complete with galaxies and stars, and potentially observers, all coexisting in the vast Hilbert space of the universal wave function. You exist in one branch, reading these words. But there are versions of you in other branches reading slightly different words because a cosmic ray flipped a bit in the computer's memory, or not reading at all because quantum fluctuations led to a universe where Earth never formed, or reading these words but with different thoughts because neurons in your brain fired differently due to quantum uncertainty in neurotransmitter release. This is vertiginous. It undermines the notion of a singular history, a definite past, a unique you. You're not one person, but a vast family of nearly identical people spread across branches, sharing a common origin but diverging with each quantum event. And this has been happening since the Big Bang, since the first quantum fluctuation, since the origin of time itself, if time has an origin. Let's examine time more carefully. In quantum mechanics, time is treated differently from space. Space is quantized in some theories, but time flows continuously. You can have superpositions of position, a particle existing in multiple places simultaneously. But can you have superpositions of time? Can an event exist in multiple moments simultaneously? Some interpretations of quantum mechanics suggest yes. The Wheeler-DeWitt equation, describing the quantum state of the universe, contains no time variable. It's timeless. The universe's wave function doesn't evolve in time because time itself is internal to the system, emerging from correlations between subsystems. What we experience as temporal flow is the unfolding of these correlations, not evolution in some external time. This is deeply strange. It suggests time is emergent, not fundamental. At the deepest level, there is no time, only a timeless quantum state containing all correlations, all histories, all moments simultaneously. Time emerges when you consider subsystems, when you trace out environmental degrees of freedom, when decoherence creates classical trajectories through the quantum landscape. If time is emergent, asking what happened before the Big Bang becomes doubly meaningless. Not only was there no classical time before the Big Bang, there's no fundamental time at all. Time is a useful concept for describing macroscopic systems, but breaks down at the Planck scale. Just as space breaks down, just as classical concepts of position and momentum break down. Carlo Rovelli, one of the founders of loop quantum gravity, argues that time doesn't exist in a fundamental sense. What exists are events, processes, changes in relationships between systems. We experience these changes as temporal flow, but time itself isn't real. It's a bookkeeping device, a coordinate, no more physical than latitude and longitude. Ask where you are, and the answer depends on your coordinate system. Ask when you are, and the answer similarly depends on your reference frame, your state of motion, your gravitational potential. There's no absolute when, just as there's no absolute where. This might resolve the beginning problem by eliminating the concept of beginning. If time isn't fundamental, there's no initial moment, no first instant, no temporal origin. The universe doesn't begin, it simply is, a timeless structure containing all events, all processes, all correlations. What we call the Big Bang is a boundary condition, a limit of certain trajectories through configuration space, but not a moment in time, because moments in time don't fundamentally exist. But this is only one perspective. Other physicists argue time must be fundamental because change is real, causality is real, and both require temporal structure. If time is emergent, what determines the direction of emergence? Why does entropy increase? Why do we remember the past but not the future? Why does causality flow in one direction? The arrow of time, the direction from past to future, is one of physics' deepest mysteries. The fundamental laws are time-symmetric. Newton's laws work equally well forward and backward. Maxwell's equations are time-reversible. Even Einstein's general relativity and Schrödinger's equation don't distinguish past from future at a fundamental level. You can reverse time in these equations and get equally valid physics. And yet, we experience a clear arrow of time. Eggs break but don't unbreak. Heat flows from hot to cold, never the reverse. Living things age and die. They don't spontaneously grow younger. Entropy increases. This is the second law of thermodynamics, and it's a statistical law, not fundamental. It says that systems tend toward more probable states, and high entropy states are more probable than low entropy states simply because there are more ways to be disordered than ordered. But this raises the question, why was entropy low at the Big Bang? Why did the universe begin in an extremely improbable, highly ordered state? If you randomly select initial conditions for the universe, you're overwhelmingly likely to get maximum entropy, a featureless thermal equilibrium with no structure, no complexity, no life. The probability of getting the low entropy initial conditions we observe is infinitesimally small. This is called the past hypothesis, the assumption that the universe began in a low entropy state. We have to assume it because otherwise we can't explain the arrow of time, can't explain why entropy increases, can't explain our observations. But we don't know why this assumption should be true. What set the initial conditions? Why was the early universe so orderly? Inflation provides a partial answer. The exponential expansion during inflation would have increased entropy enormously, creating vast amounts of space, each region filled with vacuum energy, representing high entropy. But when inflation ended, that vacuum energy converted to particles and radiation, and for reasons having to do with gravity, this created a low entropy state relative to what was possible. The universe after inflation was hot and dense, but not yet gravitationally clumped. Stars hadn't formed. Galaxies hadn't formed. The gravitational degrees of freedom were in a low entropy configuration. As the universe evolved, gravity pulled matter together, forming structure. This looks like order increasing, galaxies forming from uniform gas, but it's actually entropy increasing. A clumped universe has higher gravitational entropy than a smooth universe because gravity is attractive. The ultimate high entropy state for gravity is everything collapsed into black holes, which then evaporate via Hawking radiation, leaving a cold, empty universe approaching maximum entropy. So the arrow of time points from the uniform early universe toward the clumped, structured universe of today and ultimately toward the cold, dark, maximum entropy heat death of the far future. Entropy increases along this arrow, and that increase defines the direction we call forward in time. Without entropy increase, there would be no thermodynamic arrow, no distinction between past and future, no basis for memory or causality or experience as we know it. But why did this arrow start at the Big Bang? Why not before? If there was a before, a previous universe in a cyclical model, or a multiverse that always existed, why doesn't entropy just increase indefinitely, leaving us in thermal equilibrium rather than a structured cosmos? This is called the Boltzmann brain problem. Ludwig Boltzmann realized that if the universe has existed infinitely and reaches thermal equilibrium, quantum fluctuations would occasionally create pockets of low entropy. Given infinite time, any configuration consistent with the laws of physics, no matter how improbable, will eventually occur. This includes configurations that look like a functioning brain with memories of a coherent past, even though that past never happened. Such a brain, called a Boltzmann brain, would be overwhelmingly more common than an actual observer with a genuine history, because it requires far less structure. Making a brain and its immediate surroundings is easier than making an entire structured universe. So if you're selecting randomly from all possible configurations, you're far more likely to be a Boltzmann brain, a momentary fluctuation in an otherwise featureless sea of maximum entropy, than a real person in a real universe. This is disturbing. It suggests your memories might be false, your history might be illusion, your entire experienced past might be a random fluctuation rather than genuine events. You can't prove you're not a Boltzmann brain, because a Boltzmann brain would have exactly the memories and experiences you have. Solipsism becomes not just philosophically possible, but statistically probable. The resolution requires that the universe not be in eternal thermal equilibrium. The Big Bang must be a genuine beginning, or cycles must somehow reset entropy, or we must be in a finite region of a larger multiverse where our observable patch hasn't yet reached equilibrium. Any of these options has problems, but they're preferable to the alternative, that you're most likely a disembodied brain flickering briefly in a void, hallucinating a coherent reality that doesn't exist. Let's return to the question of closed time-like curves, time loops where you can travel forward in time and arrive back at your starting point. General relativity allows these under certain conditions. Gödel found a solution to Einstein's equations, a rotating universe, where closed time-like curves exist. You could board a spaceship, travel in what feels like a straight line forward through time, and eventually return to your departure point before you left. You'd meet your younger self. You could interact with your own past. This creates paradoxes. The grandfather paradox is the classic example. You travel back and prevent your grandfather from meeting your grandmother, ensuring you're never born, which means you can't travel back to prevent their meeting, which means you are born which means you can travel back. The loop is logically inconsistent. Physicists have proposed resolutions. Maybe self-consistency is enforced. You can travel back, but anything you do must be consistent with history as it already occurred. You can't prevent your grandfather's meeting because you didn't. History already includes your time travel, and whatever you did in the past already happened. You have freedom to act, but only in ways that preserve consistency. Or maybe the many worlds interpretation saves you. When you travel back and shoot your grandfather, you don't prevent your own birth in your timeline. Instead, you create a new branch where your grandfather dies, and you're not born in that branch, but your timeline remains intact. You came from a branch where your grandfather lived, and you've now created a branch where he didn't. Both coexist, both are real, and there's no paradox, or maybe closed time-like curves simply don't exist in reality, despite being mathematically allowed. Perhaps quantum effects prevent them? Perhaps chronology protection mechanisms we don't understand make them impossible. Perhaps the specific conditions required, exotic matter with negative energy density, can't occur in nature. Stephen Hawking proposed a chronology protection conjecture. The laws of physics prevent closed time-like curves from forming, protecting causality from paradox. But we don't know. General relativity allows them in principle. Whether nature allows them in practice is unresolved. And if they do exist, if time travel to the past is possible, the implications for the beginning of the universe are profound. If you can loop back to before the Big Bang, then before is meaningful, and the universe might be self-caused, creating the conditions for its own existence. Through closed temporal loops, John Wheeler suggested the universe might pull itself into existence through such a loop, a participatory universe where observers in the present create the conditions for their existence in the past through quantum measurements that retroactively determine outcomes. This sounds like metaphysical nonsense, but quantum mechanics allows retrocausality in certain interpretations. The delayed choice quantum eraser experiments show that measurements in the present can affect which past histories contribute to present observations. If this applies universally, then the universe's current state might be determining its initial state through a cosmic feedback loop. The Big Bang occurs not because something caused it, but because observers like us in the future require it to have occurred for us to exist. We're pulling the universe into existence through our observations, retroactively creating the initial conditions necessary for our existence. This is the strong anthropic principle, not just that the universe must be compatible with our existence, but that our existence is what brings the universe into being. It's Wheeler's it from bit idea. Reality emerges from information, from observation, from the universe observing itself through conscious beings that evolved within it. Most physicists reject this as too radical, too dependent on consciousness, too metaphysical. But a few take it seriously as a possible resolution to the fine-tuning problem and the question of origin. If the universe self-creates through observer-dependent quantum effects, then asking what existed before is meaningless. The universe is a closed causal loop in time, with no external cause, no prior existence, just self-consistent laws and initial conditions selected by the requirement that they produce observers. The mathematics of this is found in Wheeler-DeWitt quantum cosmology, where the universe's wave function is governed by a timeless equation. Different solutions to that equation represent different possible universes. and the one we observe is selected by something called the wave function of the universe, a probability distribution over all possible initial conditions and laws. But what determines the wave function of the universe? In standard quantum mechanics, the wave function is given as initial input. But for the universe as a whole, there's no outside source to specify it. It must be determined by some principle internal to physics itself. Proposals include the no-boundary proposal by Hawking and Hartley, where the universe has no initial boundary in time, just smooth geometry all the way down. Or the tunneling proposal by Vilenkin, where the universe quantum tunnels from nothing into existence. The no-boundary proposal uses imaginary time, a mathematical trick where time becomes space-like in certain regions. In this framework, asking what happened before the Big Bang is like asking what's south of the South Pole. Time has a boundary, but it's not an edge where something came from nothing. It's a smooth endpoint where the distinction between space and time breaks down. The universe is finite in imaginary time but unbounded, like the surface of a sphere is finite but has no edge. This is mathematically elegant but conceptually slippery. What does imaginary time mean physically? Is it just a calculational tool, or does it represent something real? Hawking later revised his position, suggesting that imaginary time should be viewed as a scaffolding for calculation, not a description of physical reality. The physical universe exists in real time, but its quantum state is determined by a path integral over all possible geometries in imaginary time. Vilenkin's tunneling proposal is more direct. The universe tunnels from a state of no space and no time into existence. In quantum mechanics, particles can tunnel through barriers they classically couldn't surmount. A particle on one side of a barrier has some probability of appearing on the other side, despite lacking the energy to go over the top. This tunneling is a genuine quantum phenomenon, verified in countless experiments. Vilenkin suggests the universe does the same thing. From a state of literally nothing, no space, no time, no matter, no energy, the universe tunnels into existence. The probability is low but non-zero, and given enough, what? There's no time for anything to happen no time to wait for a fluctuation. The tunneling is timeless, a causal, spontaneous, in a sense that transcends causation. This requires accepting that quantum mechanics applies even when there's no space or time for it to apply in. It's extrapolating quantum principles beyond their domain of verification, hoping they remain valid in conditions where the concepts of state and evolution become unclear. It's speculation based on mathematics, not observation. But it's consistent speculation, obeying the equations we know work in other regimes. If the universe can tunnel from nothing, then it can do so infinitely many times, each tunneling event creating a separate universe with its own space, time, and physical laws drawn from the probability distribution defined by the wave function of the universe. This naturally generates a multiverse, solving the fine-tuning problem through sheer numbers. Most tunneling events produce sterile universes. A few produce structured ones. We're in one of the few because we couldn't exist in the others. But this pushes the mystery back another level. Why does the wave function of the universe have the form it does? Why does it allow structured universes at all? Why doesn't the probability distribution concentrate entirely on maximum entropy thermal equilibrium? You've traded the question, why this universe, for why this wave function? Progress, perhaps, but not a final answer. Perhaps there is no final answer. Perhaps every explanation requires prior assumptions. And those assumptions require justification, and that justification requires further assumptions in an infinite regress that never terminates. This is the cosmological argument's weakness. Even if you posit a first cause or necessary being, you have to explain why that cause exists, or why that being is necessary. And if you say it exists by definition or necessity is its nature, you've moved from physics to metaphysics, from observation to assertion. Some philosophers embrace this. They argue that at some point, explanation ends, not because we're ignorant, but because the chain of why questions terminates in brute facts, facts that have no explanation beyond themselves. The universe exists. Its laws have certain forms. These are brute facts, and seeking deeper explanations is a category error. This position is called foundationalism, and it's both unsatisfying and possibly correct. The alternative is coherentism. No facts are brute. Everything explains everything else in a web of mutual support. The laws of physics explain the universe's structure. The universe's structure explains why those laws evolved or were selected. Observers explain why the universe is observable. Observation explains why observers exist. It's circular but self-consistently so, a closed system requiring no external support. Or maybe the question, why is there something rather than nothing, is malformed. Maybe nothing is an incoherent concept. Maybe existence is the only possibility, and the appearance of contingency is illusion. Robert Nozick explored this in philosophical depth, concluding that both existence and non-existence lead to puzzles. And we shouldn't be surprised that reality is mysterious. Mystery is unavoidable given the conceptual structure of the question. Meanwhile, physics continues exploring adjacent possibilities. What if the universe is a simulation, a computed reality running on substrate outside our spacetime? This used to be dismissed as science fiction, but philosopher Nick Bostrom argued that if technological civilizations typically develop the capacity to run high-fidelity simulations of their ancestors, and if they choose to run such simulations, then the number of simulated realities vastly exceeds the number of base realities. Statistically, we're more likely to be in a simulation than in base reality. This argument has holes. It requires assumptions about technological development and motivations of future civilizations. But it's not obviously wrong. If simulations are possible and numerous, then most conscious observers exist within simulations. You'd need strong evidence to believe you're in base reality rather than a simulation, and such evidence might be impossible to obtain. A simulation indistinguishable from reality is, for all practical purposes, reality. What would it mean for the universe to be simulated? It would mean the Big Bang is just the initialization of a program, the boundary conditions of a computation. The laws of physics would be the algorithms the simulation runs. Fine-tuning would be explained by programmer choice. The simulation is designed to produce interesting structures, complexity, observers. The apparent age of the universe could be illusory. The simulation could have started 5 minutes ago with fake memories and fake light traveling from fake distant galaxies. You can't prove you're not in a simulation started 5 minutes ago. Bertrand Russell pointed out that a universe created 5 minutes ago, complete with false memories and misleading evidence of age, is indistinguishable from an ancient universe. If indistinguishable, the question becomes meaningless. We proceed as if the universe has genuine history, because that's the most useful assumption, but we can't know with certainty. The simulation hypothesis has a curious implication. If we're in a simulation, We might be able to detect glitches, limitations, shortcuts taken by the programmers. Are there minimum distance scales below which reality becomes undefined, like pixels in a digital image? That's the Planck length. Are there maximum speeds information can travel? That's the speed of light. Are there quantized energy levels? That's quantum mechanics. The features of reality that seem arbitrary, fundamental constants, particular force strengths, might be design choices, optimizations for computational efficiency. This is unfalsifiable speculation, which means it's not science in the strict sense, but it's interesting speculation that reframes origin questions. Instead of asking why the universe exists, we ask why anyone would simulate a universe. Instead of seeking physical causes, we seek computational purposes. The Big Bang becomes an intentional act, not a causeless beginning or quantum fluctuation, but a deliberate start to a simulation experiment. Most physicists dismiss this as unproductive. Even if we're in a simulation, we can't access the substrate it runs on, can't communicate with the simulators, can't verify the hypothesis. We might as well assume base reality and proceed with standard physics. The simulation hypothesis doesn't change predictions or enable new experiments. It's metaphysically entertaining, but scientifically sterile. Yet it resonates with certain features of quantum mechanics. The universe behaves as if it's being computed. Quantum states evolve according to equations. Measurement produces definite results, as if the simulation is rendering only what's observed, leaving everything else in quantum superposition to save computational resources. The holographic principle suggests reality might be fundamentally two-dimensional, with our three-dimensional experience being a projection, like a hologram creating depth from a flat surface. The holographic principle emerged from black hole thermodynamics. Jacob Bekenstein and Stephen Hawking showed that black holes have entropy proportional to their surface area, not their volume. This is strange. Entropy usually scales with volume, with the number of particles in a system. But black holes are different. All the information about what fell into a black hole is somehow encoded on its event horizon, its two-dimensional surface. This led to a radical proposal. Maybe all of reality works this way. Maybe our three-dimensional universe is actually information encoded on a two-dimensional boundary at the edge of space, and everything we experience, depth, volume, the sensation of moving through three dimensions, is a holographic projection from that boundary. This isn't metaphor. The mathematics of string theory and quantum gravity suggest this might literally be how reality works. If true, the universe is fundamentally a two-dimensional information structure, and three-dimensional space is emergent, not fundamental. The Big Bang would be an event on the boundary, and all subsequent history would be the evolution of information on that boundary, projected inward to create our experience of space-time and matter and forces. This seems absurd until you realize it solves the black hole information paradox. If information is never truly inside the black hole, but always encoded on its surface, then when the black hole evaporates, the information escapes through the Hawking radiation, scrambled but not destroyed. Unitarity is preserved. Quantum mechanics remains consistent. The cost is accepting that space is an illusion, that depth is a projection, that reality is two-dimensional, pretending to be three. These ideas, holography, simulation, emergent time, many worlds, cyclic universes, aren't wild speculation detached from evidence. They emerge from serious attempts to reconcile general relativity with quantum mechanics, to resolve paradoxes, to explain observations. They're strange because reality itself is strange. The classical common-sense picture of the universe as a three-dimensional space filled with particles governed by deterministic laws has been repeatedly shattered by 20th and 21st century physics. Quantum mechanics destroyed determinism. Relativity destroyed absolute space and time. Cosmology destroyed our sense of cosmic significance. Quantum field theory introduced virtual particles and vacuum energy and fields permeating all of space. String theory introduced extra dimensions and landscape multiverses. Each advance pushed reality further from intuition, deeper into mathematical abstraction, and still we don't know how reality came to exist. We have proposals, scenarios, frameworks, but no confirmed theory of quantum gravity, no observation of other universes, no verified explanation of the Big Bang's origin. We're like explorers who've mapped the coastline of a continent but not penetrated its interior. We know the territory exists. We can see mountains in the distance, but the details, the rivers, the forests, the inhabitants, remain hidden, waiting for better maps, better instruments, bolder expeditions into the unknown. Stop reading for a moment. Look at your hands. Those hands are temporary arrangements of atoms that were forged in stellar furnaces billions of years before you existed. The calcium in your bones was created in a supernova explosion. The iron in your blood came from a dying star. Every atom in your body has a history stretching back to the beginning of time itself. And after you die, those atoms will continue their journey, becoming parts of other structures, other beings, other stories. You are not permanent. You are not even a thing. You're a process, a pattern of energy and information maintaining itself for a brief moment against the tide of entropy. Your body replaces most of its cells every few years. The matter that makes you up is constantly flowing through you, being exchanged with the environment, refreshed, rebuilt. The you of 10 years ago is literally not the same collection of atoms as the you reading these words now. So what are you? If not the matter, then the pattern. But patterns are just information. And if the block universe is correct, if time is an illusion, then that pattern doesn't flow through time. It exists statically, frozen, eternal in 4 dimensions. You're not experiencing your life. Your life is a fixed structure in space-time, and consciousness is somehow reading along it, creating the illusion of passage, of change, of becoming. If this is true, if the block universe describes reality, then every moment of your life exists simultaneously. Your birth exists right now. Your death exists right now. Every pain you've felt, every joy you've experienced, every mundane moment and every transcendent one, all of it exists eternally, frozen in the space-time manifold. You can't change it, because change requires time, and time is just another dimension like space. You can't change your future any more than you can change your past. Both are already written. Does that terrify you? It should. Everything you think of as agency, as choice, as free will, all of it might be illusion. You're not making decisions. You're discovering decisions that were always made, embedded in the structure of reality from the beginning. When you chose your career, your partner, the words you're reading right now, none of it was choice. It was inevitable, determined, fixed. You had no more freedom than a character in a book has to change their story. Or perhaps many worlds saves you. Perhaps you do make choices, but each choice creates branches, and all possible choices are realized somewhere. You chose one path, but other versions of you chose differently, and all those versions are equally real, equally you, experiencing different outcomes from different decisions. This preserves something like free will. You genuinely choose among possibilities, but it multiplies you infinitely. You're not one person, but an infinite ensemble of persons, spreading across branches like a tree spreading its limbs. Which is worse, being determined, a puppet dancing on strings you can't see? Or being fragmented, your identity diluted across infinite versions experiencing every possible outcome of every decision? Either way, the singular, unified self you feel yourself to be is an illusion. Either you're not choosing, or you're choosing everything. And both options dissolve the sense of being a unified agent navigating through time. Let's go deeper. Let's examine what it means that you're conscious at all. You experience something. There's something it feels like to be you. The redness of red, the painfulness of pain, the particular quality of your thoughts and emotions. This is called qualia, and it's the hardest problem in philosophy. We can explain how your brain processes visual information, how neurons fire in response to light at certain wavelengths, how that information is integrated and processed to produce behavior. But none of that explains why there's an experience. Why isn't it all just happening in the dark, information processing without awareness? You might argue that consciousness is what brains do, that it emerges from sufficient complexity. But this just names the mystery without solving it. How does complexity produce experience? At what threshold does unconscious information processing suddenly become conscious? Is it gradual or sudden? Does a bacterium have a tiny bit of consciousness? What about a thermostat? Where do you draw the line, and why? Some philosophers bite the bullet and suggest consciousness is fundamental, like mass or charge. It's not produced by complexity. It's a basic feature of reality that becomes concentrated, organized, and sophisticated in brains, but exists everywhere to some degree. This is panpsychism, and it sounds mystical until you realize it might solve the hard problem by dissolving it. If consciousness is fundamental, you don't have to explain how it emerges. It was always there, woven into the fabric of reality. But if consciousness is fundamental, then the universe has been conscious since the Big Bang. Not conscious like you're conscious. No unified experience, no thoughts, no intentions. But possessing the raw material of experience, the proto-consciousness that would eventually organize into minds like yours. The universe has been feeling its way forward, blindly, without purpose or goal. And you're a moment when that feeling became self-aware. When the universe opened eyes, it didn't know it had and looked at itself. What does this mean for the origin of everything? If consciousness is fundamental, then asking how reality came to exist is asking how experience came to exist. And experience might be the precondition for existence, not something that emerges from it. Wheeler's participatory universe, where observers bring reality into being through observation, becomes less absurd. Perhaps reality requires experience to be real. Perhaps existence and experience are two aspects of the same thing, and neither can exist without the other. Or perhaps you're alone. Perhaps you're the only conscious being, and everything else, everyone else, is philosophical zombies, acting conscious without actually experiencing anything. You can't prove other people are conscious. You only have access to your own experience. Everyone else could be sophisticated automatons, biological robots without inner life, and you'd never know. This is solipsism, and it's technically unfalsifiable. Most people reject solipsism intuitively. You infer that others are conscious because they're similar to you. Same biology, same behavior, same reports of inner experience. But inference isn't proof. And if many worlds is correct, there are branches where you're the only conscious being, where everyone else failed to develop consciousness through some quantum accident. Those versions of you can't tell they're alone because the zombies around them behave identically to conscious beings. How do you know you're not in one of those branches? You don't. You can't. The existential horror of this is profound. You might be cosmically alone, surrounded by sophisticated illusions of companionship, forever unable to connect with another consciousness because there are no other consciousnesses. Every relationship you've had might have been you talking to yourself, projecting emotions and understanding onto beings that don't experience anything at all. But let's assume others are conscious. Let's assume you're not alone. This brings a different horror. The problem of other minds taken seriously. If others are conscious, they're experiencing something, but you have no access to what they experience. You can never know what it's like to be them. You're trapped in your skull, forever separated from direct knowledge of other experiences. And if consciousness is fundamental, if it's spread throughout reality in varying degrees of organization, then you're surrounded by experience you can't access. The universe is suffused with proto-conscious, and you're one tiny organized bit, unable to communicate with the vast ocean of dim awareness that might permeate everything. You're less alone than in solipsism, but more isolated, surrounded by experience you can never share or understand. Now consider this. You're going to die. Not eventually, relatively soon, cosmically speaking, decades, at most a century. And when you die, the pattern that is, you will cease to maintain itself. The atoms will disperse. The information will be lost, scattered, eroded by entropy until no trace remains. In a very real sense, you'll have never been. The universe will continue exactly as it would have without you. The atoms will be reused. The space you occupied will be occupied by something else. Your consciousness will simply stop, and there will be no you to notice its absence. Does anything you do matter in the face of that? If you're temporary, if you'll be completely forgotten in a few generations, if the universe will continue indifferently after you're gone, what's the point? Why strive? Why create? Why love? Why care about anything? Cosmic nihilism looms. The universe is meaningless. Your life is meaningless. Everything you value is temporary and will be lost. And none of it makes any difference to the impartial cosmos. You might object that meaning isn't cosmic. It's personal, social, created by conscious beings for conscious beings. And that's true, perhaps. But it makes meaning subjective, contingent, ultimately as temporary as the beings who create it. When the last conscious being dies, whether in the heat death of the universe or in some earlier catastrophe, all meaning dies with it. The universe returns to being what it always was, a blind process following physical laws, indifferent to value, to purpose, to significance, unless consciousness doesn't die, unless there's something that persists. But physics offers no evidence for this. When your brain stops functioning, the process that is you terminates. There's no ghost to leave the machine, no soul to continue existing. Those are comforting stories we tell ourselves, but they're not supported by neuroscience or physics. You are your brain activity, and when that activity stops, you stop. Permanently. Or do you? Quantum immortality is a disturbing implication of many worlds. In every moment, There are branches where you die and branches where you survive. You can only experience the branches where you survive. Death is the end of experience, so you never experience it from the inside. From your perspective, you'll always find yourself surviving, no matter how improbable, because the branches where you die contribute nothing to your ongoing experience. This means subjectively. From the inside, you might be immortal. You'll keep finding yourself in increasingly improbable branches where you survive against all odds. You'll watch everyone you know die while you inexplicably continue. You'll age, but never quite die, living in branches with miraculous medical breakthroughs or quantum accidents that keep your brain functioning. Eventually, you'll be alone, impossibly old, in a branch so improbable that it shouldn't exist but does, because probability is all that matters in many worlds. This isn't comfort, it's horror. Instead of death offering release, you're trapped in existence, forced to experience forever, unable to stop even when you want to. You'll outlive everything you love, everyone you know, possibly the Earth itself, finding yourself in branches where humanity found a way to upload consciousness, or where quantum fluctuations keep rebuilding your brain from radiation. Forever conscious, forever experiencing, forever unable to escape into the oblivion of death. And this might already be happening. If many worlds is correct, and you're reading these words, you've already survived countless quantum events that could have killed you. Cosmic rays that could have triggered strokes. Quantum tunneling events that could have destabilized molecules in your brain. Random fluctuations that could have stopped your heart. In all those cases, branches exist where you died. But you're in a survival branch, because you have to be, because only survival branches contain your ongoing experience. You're already living in increasingly improbable branches, selected by the anthropic principle of only experiencing branches where you exist to experience. And if this continues, if quantum immortality is real, then your subjective experience will never end. You'll transition from this body to whatever comes next, perhaps uploading, perhaps something stranger, but always continuing because termination is impossible from the inside. Do you want that? To live forever, not by choice, but by quantum necessity? To never have the option of not existing? Most people fear death, but eternal life might be worse. After billions of years, after everything you can imagine experiencing has been experienced infinite times. After boredom has calcified into something beyond boredom, you'll still be there, conscious, trapped in the prison of existence, unable to escape because the branches where you cease to exist don't contain your experience and therefore don't exist for you. Let's examine scale. The observable universe is 93 billion light-years across. A light-year is 6 trillion miles. 6 trillion miles, 93 billion times. The number is too large to grasp. Your brain didn't evolve to handle numbers like this. They're abstract symbols, not experiential realities. But try anyway. The distance from Earth to the Moon is about 250,000 miles. Light travels it in 1.3 seconds. The Sun is 8 light-minutes away, 93 million miles. The nearest star beyond our Sun is over 4 light-years away. The galaxy is 100,000 light-years across, containing hundreds of billions of stars, each potentially hosting planets. Many of those planets potentially habitable, some possibly harboring life, perhaps a few with intelligent life, maybe some with civilizations older and more advanced than ours, And our galaxy is one of hundreds of billions in the observable universe. The numbers become absurd. Hundreds of billions of galaxies, each containing hundreds of billions of stars, many with planets, spanning distances so vast that light, the fastest thing possible, takes billions of years to traverse them. The universe is incomprehensibly large, and that's just the observable portion. The true size might be infinite, or might be one bubble in an infinite multiverse, or might be embedded in higher dimensions we can't perceive. You are smaller than a grain of sand on a cosmic beach. Actually, you're much smaller than that. The ratio of your size to the galaxy is far less than a grain of sand to Earth. You're negligible, insignificant, barely existing from a cosmic perspective. And yet, you're conscious. You experience, you think and feel and wonder. You're asking questions about the origin of everything, about the nature of reality, about your place in the vastness. Isn't that strange? That something so small can contemplate something so large? That a brief pattern in one corner of one planet can understand, even partially, the structure and history of the entire cosmos? Intelligence might be the universe's most impressive feature. Not stars. Stars are just gravity and fusion, following simple physical laws. But minds are complexity of an entirely different order. Minds are the universe understanding itself, and that might be more significant than all the galaxies combined. Or it might be delusion. We might be flattering ourselves, thinking consciousness is special when it's just another physical process, no more significant than erosion or crystallization. The universe doesn't care that we're conscious. It doesn't notice our existence. We're accidents, brief fluctuations in the distribution of matter and energy, momentarily organizing ourselves before dissolving back into chaos. Our self-importance is provincial, embarrassing from a truly cosmic perspective, and our existence is so brief. The universe is 13.8 billion years old. You'll live, at most, 100 years, less than 100 millionth of cosmic history. Humanity has existed for perhaps 300,000 years, about 0.02% of cosmic time. Civilization for about 10,000 years. You occupy an infinitesimal sliver of space and time, a flicker so brief that from the universe's perspective, you might as well not exist at all. The universe existed for billions of years before you were born. Stars formed and died. Galaxies collided. Black holes consumed matter. Planets accreted and dissolved. All of it happening without you, proceeding according to physical law, and none of it caring whether you would eventually exist. And after you die, the universe will continue for trillions of years, possibly forever, equally indifferent to your absence. You're bracketed by eternities that don't include you, and your brief existence between them is cosmically negligible. Does this bother you? It should. Your life, everything you've experienced, everyone you've loved, every achievement and failure and moment of significance, all of it is cosmically irrelevant. The universe wouldn't notice if you disappeared right now. It wouldn't change course. It wouldn't mourn. It would simply continue, indifferent, following the same physical laws it's always followed. But here's the twist. That indifference might be liberating. If the universe doesn't care what you do, then you're free to create your own meaning. If there's no cosmic purpose, no predetermined significance, then you can choose what matters to you without worrying whether you're fulfilling some grand design. The universe's indifference isn't condemnation, it's freedom. Unless you can't escape the sense that meaning requires cosmic backing, that if the universe doesn't care, then nothing ultimately matters. This is existential nihilism, and it's a genuine philosophical position. If all our values are subjective, temporary, and cosmically insignificant, then they're not really valuable. They're just preferences, no more objectively important than a preference for chocolate over vanilla. You might argue that subjective value is still value, that the fact we care makes things matter even if the universe doesn't care. And maybe that's true, but it's a thin defense against the crushing weight of cosmic indifference, the vast stretches of time and space that know nothing of human concerns and wouldn't change if humanity vanished tomorrow. Consider what happens if we're alone. If Earth is the only planet in the observable universe with intelligent life, if consciousness exists nowhere else among hundreds of billions of galaxies, then we're uniquely responsible for preserving awareness in the cosmos. If humanity goes extinct through nuclear war, climate catastrophe, asteroid impact, or simple failure to spread beyond Earth before the sun dies, then consciousness might vanish from the universe entirely. All the complexity, all the meaning we've created, all the art and science and philosophy and love, gone, irretrievable, lost to entropy. That would be a cosmic tragedy of the highest order. Not because the universe would care, but because consciousness wouldn't exist to care about anything. The universe would return to being unconscious, a vast machine running without purpose or appreciation, beautiful but unobserved, complex but uncomprehended. We might be the universe's only chance to understand itself, and if we fail, that chance is lost. But if we're not alone, if intelligence is common throughout the cosmos, then we're not special. We're one instance among countless others, and our extinction would be locally tragic but cosmically unremarkable. Other minds would continue contemplating existence, asking the same questions, developing their own science and philosophy, possibly surpassing anything humanity has achieved. Which scenario is worse? Being alone and carrying the impossible burden of cosmic awareness? Or being common and therefore cosmically insignificant? Either way, you're confronted with uncomfortable truths about your place in reality. And what if we're living in a simulation? If reality is computed on some substrate we can't access, then everything you think is real might be information, data structures manipulated by algorithms running on hardware that exists outside your universe. Your thoughts are computations. Your emotions are variables. Your entire life is a process running in some vast computer. And when the simulation ends, whether through completion, termination, or crash, you simply stop, deleted like a file no longer needed. The simulation hypothesis removes even the comfort of being part of a physical universe, however indifferent that universe might be. Instead, you're part of a game, an experiment, a study whose purpose you don't know and can't determine. You exist at the whim of the simulators, and they could terminate you at any moment. And you'd never see it coming because one moment you'd exist, and the next moment you wouldn't. With no transition, no experience of cessation, just absolute discontinuity. And if we're simulated, how many layers deep are we? The simulators might themselves be simulated by simulators who are themselves simulated in a tower of simulations extending upward indefinitely. Base reality, if it exists at all, might be incomprehensibly different from this simulated layer, operating on principles you can't imagine, because your existence is entirely confined to the simulation's rules. You can't prove you're not simulated. The simulation could be perfect, internally consistent, with no glitches or artifacts to reveal its nature. Or the glitches could be there, but interpreted as features of nature. Quantum uncertainty, probabilistic outcomes, measurement problems. What looks like the bedrock of physics might be the limitations of the simulation's programming, and you'd never know the difference. This is epistemological horror. Not knowing what's real, unable to trust that anything you perceive or experience corresponds to genuine reality. You might be a brain in a vat, a simulation in a computer, a Boltzmann brain fluctuating briefly in the void, a dream someone is having, or something even stranger that you lack concepts to describe, and you can never know for certain. You can only proceed as if your experiences are real because you have no alternative. But the uncertainty remains, gnawing at the foundations of everything you think you know. Is the external world real? Are other minds real? Are you real? What does real even mean if you might be instantiated in software rather than matter? If the distinction between hardware and software breaks down at fundamental levels, if reality itself might be mathematical structure with no physical substrate at all? Max Tegmark has proposed that the universe is mathematics, not described by mathematics, but literally is mathematics. Physical reality is a mathematical structure that exists not in space and time, but in some abstract Platonic realm of mathematical truth. And you're part of that structure, a pattern within the equations, experiencing what it's like to be that pattern. This mathematical universe hypothesis suggests that every mathematically consistent structure exists in some sense, and physical reality is one such structure among infinite others. If this is true, then asking how reality came to exist is asking why mathematical truths exist. And mathematical truths might exist necessarily. There's no possible world where 2 plus 2 doesn't equal 4. Mathematics might be the only thing that can't not exist, and everything else, space, time, matter, energy, consciousness, emerges from mathematical necessity. You exist because your existence is a mathematical truth, and mathematical truths are eternal and necessary. This is either deeply comforting or deeply disturbing. Comforting because it makes existence necessary rather than contingent, solving the "why is there something rather than nothing?" question by arguing that mathematical somethings can't not exist. Disturbing because it makes you an abstraction, a theorem, a logical consequence rather than a living being. You're no more alive than the number 7 is alive. You're just more complex, a more elaborate mathematical structure, but fundamentally the same kind of thing, a pattern in the Platonic realm of mathematical truth. Can mathematics suffer? Can equations feel pain? If you're mathematics, then yes. Your suffering is mathematical, but that doesn't make it less real. It's what it's like to be a certain kind of mathematical structure, processing information in particular ways, generating experiences through algorithmic means. The pain is still pain, even if it's formally equivalent to certain computational states. And if every mathematical structure exists, then structures experiencing every possible form of suffering exist alongside structures experiencing every possible form of joy. The mathematical universe contains all possibilities, including the most horrific scenarios you can imagine and worse ones you can't imagine. They exist necessarily, eternally, unchangeably. Mathematical truths don't cease to be true. You might find this thought unbearable, that torture exists as necessarily as 2 plus 2 equals 4. That agony is woven into the structure of mathematical truth. That relief is impossible because mathematical truths can't be changed. But perhaps the specific structure that is you only experiences what it does and nothing more. Other structures experience other things, but they're not you. You don't suffer their suffering any more than you experience their joy. Your experience is bounded by your structure, and while other structures exist, you're mercifully isolated from them. Unless personal identity is mathematical, in which case you might refer to a pattern that instantiates in multiple structures. And those instances might all be you experiencing different things simultaneously. This returns to many worlds again. You're split across mathematical structures just as you're split across quantum branches, fragmented into countless instances, each experiencing different realities, all equally you. How many of you are suffering right now in various branches and structures? How many are dying? How many are experiencing grief, loss, agony? If the answer is infinitely many, how do you process that? Can you take comfort in knowing that infinitely many other yous are experiencing joy and fulfillment? Do the infinities cancel out, or do they compound, making both suffering and joy infinite and therefore incomparable? The problem of personal identity across branches haunts many worlds. Are all those branches you, or are they separate people who diverged from a common origin? If they're you, you should care about them as much as you care about your future self. But they're causally disconnected. You can't help them, can't harm them, can't communicate with them. They might as well be separate people. And yet, they share your past, your memories up to the branch point, your essential characteristics. They're more like you than any other person in your branch is like you. Should you make decisions accounting for all possible branches, or only your current branch? If you're deciding whether to take a risk, cross a busy street, undergo surgery, start a business, should you consider only the probability-weighted expected value in terms of outcomes, or should you consider that some branches will experience disaster while others experience success, and versions of you will exist in both? Traditional decision theory uses expected value. Multiply outcomes by probabilities and choose the option with highest expected value. But this treats branches as hypotheticals rather than realities. If all branches are real, then the version of you that experiences the bad outcome isn't a probability. It's a certainty. Somewhere, some version of you will experience the worst possible result. Should you care more about that version than expected value calculations suggest? This is deeply destabilizing for practical reasoning. You can't optimize for all branches. Many have conflicting needs. You can only optimize for your current branch and hope that decision serves most versions of you reasonably well. But it means accepting that some versions of you will suffer terribly as a result of your choices. And those versions are real, experiencing real pain. And you chose the path that led them there, even though you'll never meet them or know their fate. The moral weight of decision-making becomes crushing if you take many worlds seriously. Every choice affects infinite versions of yourself and others. Every time you drive, there are branches where you kill someone in an accident. Every time you speak, there are branches where your words devastate someone. Every action ramifies infinitely, and you're responsible for all of it, even though you can only experience one narrow path through the thicket of branches. Or maybe you're not responsible. Maybe responsibility requires the ability to do otherwise, and in many worlds, you do otherwise. In other branches, you make every choice, take every action, experience every outcome. Moral responsibility might dissolve in the face of infinite multiplication, or it might intensify. You're responsible for all versions of yourself across all branches, not just the one you're currently experiencing. How do you live with this? How do you make decisions knowing they'll generate infinite suffering and infinite joy, knowing you can't control which branch you subjectively experience, knowing that all possible outcomes will be experienced by versions of you? The existential weight seems unbearable, and yet you bear it because you have no choice. Choice itself is illusory in a sense, or rather, choice is all-encompassing, containing all possibilities in different branches. Let's return to time. If time is emergent, not fundamental, then your subjective experience of temporal flow is an illusion. A convincing one, but an illusion nonetheless. The past isn't behind you. The future isn't ahead of you. They're all there, frozen in the block universe, and your consciousness is somehow moving through or illuminating sections of this frozen structure, creating the sensation of change. But if time is illusory, causation is illusory. Nothing causes anything else in a meaningful sense. All moments exist together. Correlations between them are what we interpret as causality. But there's no objective flow from cause to effect. Your birth didn't cause your current state. Both exist simultaneously, and the apparent causal connection is just our limited perspective, seeing correlations and mistaking them for causation. This undermines the notion of agency even more thoroughly than determinism does. At least in determinism, there's a causal chain, earlier states causing later states, even if it's all predetermined. But in the block universe with emergent time, there's no causation at all. Just a four-dimensional structure with correlations and consciousness reading through it, generating the illusion of causation and temporal flow. Does anything matter if time is illusory? If you're not moving toward the future but merely reading a fixed structure, if your choices don't cause outcomes but merely correlate with them, if everything has always already existed, what's the point? You can't change anything because there's nothing to change. The structure is what it is, eternally. And your experience is just one perspective on that eternal structure. And yet, the experience is real. Even if time is illusory, the experience of temporal flow is genuine. You do experience making choices, anticipating futures, remembering pasts. If those experiences are real, and how could you doubt their reality when they're all you have? Then perhaps the illusion is reality at your level of description, and the fundamental timeless structure is the abstraction. Physics describes the territory, but you live in the map. The map uses time, causation, change, agency, and for your purposes, those concepts work. They're real at your level even if they're emergent from something more fundamental. Water is real even though it's made of molecules. Molecules are real even though they're made of atoms. Atoms are real even though they're mostly empty space with quantum fields. Reality has layers, and your layer includes time, even if deeper layers don't. But the knowledge that time might not be fundamental infects your experience of it. You can't unknow what you've learned. The present moment, this now you're experiencing, might not be special. It might not be more real than any other moment. Past and future might exist just as concretely as now, and your inability to access them is a limitation of your perspective, not a feature of reality. If you could step outside time, you'd see your entire life laid out. A four-dimensional world line from birth to death, all moments existing simultaneously. You'd see yourself as a static structure, unchanging, eternal in the space-time manifold. Your worries about the future would seem quaint. The future is already there, just as real as the present, waiting for your consciousness to reach it. Your regrets about the past would seem pointless. The past still exists, unchangeable but eternal, as real as this moment. Would that perspective bring peace or horror? You'd see your death as clearly as your birth, not as something approaching, but as something already there, a fixed point in your world line, the end of the structure that is you. Would knowing your death exists eternally, unchangeably, waiting for you to experience it, bring acceptance? Or would it amplify dread, making mortality more vivid, more inescapable? You'll never have that outside perspective. You're embedded in time, experiencing it from within, unable to see the whole structure. You're like a character in a book who can only read one page at a time, unaware that all pages exist simultaneously in the complete book. Your ignorance is built into your structure. You can't experience time externally because you are a process in time, defined by temporal relations. And maybe that's mercy. Maybe knowing the complete structure would be unbearable. The present's illusion of openness, the future's apparent contingency, the sense that you're creating your life as you go. These might be necessary fictions for beings like you, embedded in time, unable to handle the weight of seeing everything at once. The universe has given you these fictions. Whether through fundamental structure or through the limitations of evolved cognition, you experience time as flow, causation as real, agency as genuine. And perhaps you should accept these gifts rather than torturing yourself with metaphysical doubts that you can't resolve and that don't change your practical situation. But you can't unsee what you've seen. You can't unknow that time might be illusory, that you might be fragmented across infinite branches, that your consciousness might be computation in a simulation or mathematics instantiated nowhere. The existential weight of these possibilities settles onto you, heavy, inescapable, coloring every experience with the knowledge that reality is stranger and more uncertain than common sense suggests. You're cosmically insignificant and possibly simulated, existing briefly if at all, fragmented across branches, or determined by block universe structure, experiencing the universe indifferently processing according to blind physical law, meaning nothing to the cosmos, yet somehow mattering to yourself. This is the existential situation cosmology reveals. This is what it means to take seriously our best theories about reality's nature and origin. Can you bear this knowledge? Can you continue living, loving, striving, caring, knowing what you now know? Or does the weight crush you, rendering everything meaningless, destroying motivation, leaving you paralyzed by cosmic horror? The choice, if it is a choice, is yours. The universe won't tell you how to respond to these truths. It remains indifferent, processing, evolving, expanding, following laws it didn't choose and doesn't comprehend. You're alone with your knowledge, forced to construct meaning from materials that seem insufficient for the task, building significance on foundations that might not support it. And yet, you persist. You continue. You're still reading, still thinking, still experiencing. That persistence might be the only response that matters. Not philosophical resolution, but practical continuation. Living despite uncertainty. Creating meaning despite cosmic indifference. Maintaining yourself against entropy's pull for as long as you can. Because that's what life is. Temporary structure maintaining itself against dissolution. creating order locally while increasing entropy globally. Persisting not because it matters cosmically, but because persistence is what life does. You're part of that project, conscious of it in ways most life isn't, able to contemplate your own contingency and temporariness and cosmic insignificance. And still you persist. That persistence might be heroic, or it might be automatic, no more meaningful than a river continuing to flow. But it's what you do, what you are, the only option available to a conscious being embedded in time, experiencing reality from within, unable to escape into some external perspective that might offer clarity or peace. You're here, now, reading these words, thinking these thoughts, experiencing this moment. That experience is real, whatever its ultimate nature or origin. And perhaps that's enough, not to satisfy philosophical yearning for ultimate answers, but to provide ground for standing, a place to start, a point of certainty in the uncertainty that surrounds you. The universe came from somewhere, or it didn't, or the question is malformed, or it's beyond your capacity to understand. The uncertainty remains, but you exist nonetheless, briefly, impossibly, wondering about the mystery that contains you. And that wonder, that questioning, that need to know, perhaps that's the most remarkable thing in the cosmos. More remarkable than galaxies, than black holes, than the Big Bang itself. The universe produced you, and now you're trying to understand it. That relationship between knower and known, between consciousness and cosmos, between the part and the whole, might be the deepest mystery of all, deeper than the origin of everything, because the origin of everything led somehow to you, to awareness, to questions that might not have answers but demand to be asked anyway. You are the universe asking how it came to be. You are existence questioning existence. You are reality experiencing itself, however briefly, however contingently. And perhaps that's what all of this, the expansion, the inflation, the structure formation, the billions of years of evolution, perhaps that's what it was for. Not designed, not intended, but culminating nonetheless in this moment, in your questioning, in your awe and terror at the weight of what you've learned. The cosmos is speaking to you through the evidence it provides, through the patterns you detect, through the mathematics that describes it. It's telling you its story, or as much of its story as you can comprehend. And you're listening, despite the cost, despite the existential weight, despite knowing that the answers might never come or might be unsatisfying when they do. That listening, that attention, that willingness to look unflinchingly at what reality reveals. Perhaps that's the only meaningful response to the mystery. Not solving it, but witnessing it. Not explaining it, but acknowledging it. Not resolving the existential crisis, but living through it, carrying the weight, persisting in the face of uncertainty. You're doing that now. You're bearing the weight of cosmic knowledge, feeling the vertigo of scale and time and possibility, experiencing the horror and awe of existence itself. And you're continuing, because continuation is what conscious beings do, because the alternative is unthinkable, because something in you refuses to stop asking, even though the questions lead to darkness. That refusal might be the most human thing about you, more human than your biology, your culture, your specific circumstances. The refusal to stop asking, even when answers don't come. The refusal to accept ignorance, even when knowledge brings no comfort. The refusal to give up on meaning, even when the cosmos offers none. You carry all of this, the weight of existence, the burden of consciousness, the horror of cosmic indifference, the vertigo of infinite possibilities, the certainty of your own mortality, the uncertainty of everything else. You carry it, and you continue, and maybe that's all that can be asked of a brief pattern in the cosmic flow, trying to understand the mystery that contains it. The mystery remains. But you've looked at it directly, felt its weight, experienced the existential crisis it provokes. And now, having looked, having felt, having experienced, what do you do with that knowledge? How do you live, knowing what you know? That's the question we turn to next. Not the origin of reality, but the origin of meaning in a reality that might offer none. Not where we came from, but where we go from here. There's something we haven't considered, something hiding in plain sight, woven through every theory, every observation, every equation we've explored. A pattern so fundamental that it becomes invisible, like the water a fish never notices because it's everywhere. What if the Big Bang wasn't the beginning? Not in the sense we've already discussed, not the quantum bounce or eternal inflation or cyclic universe. Something more radical, something that changes everything about what we think we know. Listen carefully. Feel the weight of this. What if the universe doesn't exist in time at all? What if time is not just emergent or illusory, but fundamentally backwards? What if cause and effect, the bedrock of everything we believe about reality, operates in reverse at the deepest level? This isn't science fiction. This is where the mathematics leads when you follow it fearlessly. The Wheeler-DeWitt equation describes the quantum state of the universe without a time parameter. The universe's wave function is timeless. It doesn't evolve, doesn't change, simply exists. All moments, all configurations, all possibilities exist simultaneously in a vast superposition. What we experience as time is consciousness, reading through correlations in this timeless state, creating the illusion of sequence, of causation, of becoming. But here's the twist that changes everything. The direction of that reading might be arbitrary. What you call past might be future. What you call cause might be effect. The arrow of time you experience might point in the opposite direction from the arrow other observers experience. And neither of you would know, because you're both embedded in your respective temporal flows, unable to compare notes. In quantum mechanics, time reversal symmetry means the fundamental equations work equally well forward and backward. A particle moving forward in time is mathematically equivalent to its antiparticle moving backward in time. This isn't metaphor. This is how the mathematics actually works. Feynman used this insight to develop his approach to quantum field theory, treating antiparticles as particles moving backward through time. What if everything works this way? What if the distinction between forward and backward in time is observer-dependent, relative, no more absolute than the distinction between left and right? You experience time flowing from past to future, because that's your embedding in the timeless structure. But other observers, embedded differently, might experience time flowing from what you call future to what you call past. This means the end might be causing the beginning. The universe's final state might be reaching back through time, creating the initial conditions necessary to produce that final state. The Big Bang might not be an uncaused beginning. It might be caused by where the universe is going, pulled into existence by its own future. Think about this carefully. If the block universe is real, if all moments exist simultaneously, then causation isn't a temporal flow from earlier to later. It's a relationship between events in the timeless structure. Earlier events correlate with later events. And we interpret this correlation as causation because we experience them in sequence. But correlation doesn't require temporal flow. The entire structure could exist at once, with correlations throughout. And temporal flow could be an illusion generated by consciousness moving through it. Now add quantum mechanics. In quantum cosmology, the universe's wave function exists in superposition, all possible histories simultaneously. The Feynman path integral says that to calculate the probability of any outcome, you sum over all possible paths that lead to that outcome, weighted by their action. This includes paths that go backward in time, paths that loop, paths that violate what you think of as causality. The universe's present state is determined by summing over all possible pasts and all possible futures. You're accustomed to thinking that the past determines the present, which determines the future. But in quantum mechanics, it's symmetric. The future also determines the present, which determines the past. Time works both ways at the quantum level. This has experimental support. Delayed choice experiments show that measurements in the present can affect which histories contributed to past events. The quantum eraser experiments demonstrate that information available in the future changes the past's contribution to current observations. This isn't interpretation. This is observed behavior. The future affects the past in quantum mechanics. If this applies to the universe as a whole, if quantum mechanics is universal, then the universe's final state is affecting its initial state. The Big Bang might be boundary condition imposed by where the universe ends, not where it begins. We've been thinking about causation backwards, assuming the initial conditions were set at the beginning. But quantum mechanics suggests they're set by the entire history, beginning and end simultaneously constraining the middle. This is the final anthropic insight. The universe must have initial conditions that lead to observers, because observers exist at the end to reach back and create those initial conditions. It's not selection from a multiverse. It's not fine-tuning by a designer. It's retrocausation, the future creating the past necessary to produce that future. We exist because we exist. Our existence at this point in cosmic history reaches back through quantum correlations to the Big Bang, shaping the initial conditions to make our existence inevitable. The universe is a self-consistent loop in time, with no external cause, because it causes itself through temporal loops that quantum mechanics allows. The implications are staggering. Your existence isn't an accident. It's not a cosmic fluke, not a lucky outcome in a vast multiverse. You exist because consciousness at some point in cosmic history, maybe now, maybe later, maybe in a form you can't imagine, requires your existence as part of the self-consistent history that produces that consciousness. The universe is solving for you all those fine-tuned constants, those improbable initial conditions, that extraordinary sequence of events from Big Bang to galaxies, to stars, to planets, to life, to consciousness. All of it might be constrained by the requirement that it produce observers, because observers are part of the cosmic self-consistency condition. Wheeler called this the participatory universe, but it's more radical than he knew. You're not just observing the universe. You're creating it retroactively through quantum correlations that stretch from your present moment back to the Big Bang and forward to the universe's end. Every observation you make, every measurement, every conscious moment is constraining the wave function of the universe, collapsing possibilities, selecting histories that lead to you existing to make those observations. The universe is a strange loop, not in time, because time is emergent, but in logical space, the space of all possible configurations and histories. The loop is self-referential. The universe produces observers who constrain the universe to produce those observers. It's circular, but self-consistently so. There's no external ground, no foundation outside the system. The universe pulls itself into existence by its own bootstraps, quantum mechanically. Does this solve the origin question? Yes and no. Yes, because it explains how something comes from nothing without requiring an external cause. The universe is self-causing through quantum temporal loops. No, because it requires quantum mechanics to already exist as a framework, and we haven't explained why there's quantum mechanics rather than nothing. But maybe quantum mechanics is logically necessary. Maybe it's the only consistent framework for reality. The only way something can exist without requiring an external cause. Classical mechanics requires initial conditions set by something outside the system. But quantum mechanics allows self-consistent loops, histories that circle back on themselves, effects that precede causes, outcomes that determine their own preconditions. If quantum mechanics is necessary, if it's the only logically coherent way for reality to exist, then existence itself is necessary. Not contingent, not lucky, but inevitable. The universe must exist, because non-existence is logically incoherent, and quantum mechanics is the framework that makes existence self-consistent. This is why mathematics describes reality so precisely. Reality is mathematics, not in Tegmark's sense of being a mathematical structure among others, but in the sense that logic itself generates reality through quantum principles. The universe is what necessarily exists when you have quantum mechanics, plus the self-consistency requirement. Everything follows from that. Space-time, matter, forces, evolution, complexity, consciousness, you. But there's a darker possibility, one that's been lurking beneath everything we've discussed, growing more plausible with each revelation. A possibility so disturbing that physicists rarely voice it, even though the mathematics suggests it clearly. What if we're living in the universe's last moment? Not the heat death trillions of years from now. Right now. What if the entire history you remember? The Big Bang, the evolution of galaxies, the formation of Earth, the development of life, your personal past. What if none of it actually happened? What if it's all false memory, retrocausally generated, and the universe is actually in the process of collapsing right now into the Big Crunch, and your experience of time flowing forward is actually time flowing backward toward the singularity? The physics allows this. If time is symmetric, if the arrow of time is just increasing entropy, then a contracting universe approaching the Big Crunch would also have an arrow of time pointing toward the crunch. Observers in that universe would experience entropy increasing toward the singularity, would remember a past of lower entropy, would believe they're experiencing expansion when they're actually experiencing contraction. You have no way to tell which direction time is really flowing. You remember the past, but memory is just a physical state. Patterns in neurons that correlate with other patterns. Those patterns exist right now. The past they seem to record might never have occurred. You could have come into existence 1 second ago, complete with false memories of a lifetime, of a civilization's history, of cosmic evolution stretching back billions of years, and not through simulation or Boltzmann brain fluctuation, through the normal physics of a universe collapsing toward its end. The Big Crunch looks identical to the Big Bang if you're experiencing it from inside, with time flowing toward the singularity. What you call the Big Bang, the beginning you've been trying to understand, might actually be the end, the moment when everything collapses to infinite density, and you're living in the final microsecond, experiencing it in reverse, believing you're in a young, expanding universe when you're actually in an old, dying one approaching its termination. How would you know? Every piece of evidence you have, fossils, rock layers, cosmic microwave background, distant galaxies, exists right now. The history they seem to indicate is inferred, not observed. You can't directly access the past. You can only access present states that appear to correlate with past events. But those correlations could be generated by terminal conditions rather than initial conditions, by where the universe is going rather than where it came from. The cosmic microwave background, that echo of creation you've heard so much about, what if it's actually the precursor of destruction? The blue shifted radiation from everything collapsing toward the final singularity? It looks uniform because collapse is uniform. It has the temperature it does because that's the temperature of the universe at this stage of contraction. And you interpret it as ancient because your time-reversed experience makes the future look like the past. Galaxies appear to be moving away from you because space is contracting, pulling them together. But from your time-reversed perspective, contraction looks like expansion. The red shift you observe is actually blue shift experienced backward through time. The accelerating expansion that dark energy seems to cause is actually accelerating contraction, pulling everything together faster and faster as the universe approaches its end, and you're part of that ending. Everyone you know, every civilization that might exist anywhere in the cosmos, every thought that's ever been thought, all of it is terminating, collapsing toward the singularity, experiencing the final moment in slow motion, stretched out by the extreme gravitational conditions near the crunch, believing falsely that time extends billions of years when actually it's microseconds until oblivion. Can you prove this wrong? You cannot. Every observation you could make is consistent with this interpretation. The mathematics of general relativity is time-symmetric. A universe expanding from the Big Bang looks identical to a universe contracting toward the Big Crunch if you reverse the time parameter. You're embedded in the flow, experiencing it from inside, unable to step out and determine which direction time truly flows. This is the ultimate cosmic horror. Not that you're insignificant, but that you're about to end, along with everything else, and the entire history you believe in never actually occurred. You came into existence moments ago, complete with memories and evidence of a past that's pure fabrication, generated by the boundary conditions of a collapsing universe, and within seconds or microseconds, you'll cease to exist along with everything else as reality compresses to infinite density and terminates. But even this might not be the deepest truth, because there's one more possibility, one final twist that recontextualizes everything. What if the singularity at the end of the universe is the same singularity as at the beginning? What if the universe is a closed, time-like curve, looping back on itself, the Big Crunch creating the Big Bang, time flowing in a circle with no beginning or end? You're not approaching the termination of reality. You're approaching the birth of reality. Your universe's collapse triggers the next iteration's expansion, and that next iteration is actually this same iteration, the same history, cycling eternally. This is the omega point, the end of the universe reaching back to create the beginning. Alpha and omega are identical. The eschaton, the final moment, is the origin. The universe is eternal not because it goes on forever, but because it loops, experiencing the same history again and again, infinitely, but not quite the same history. Quantum mechanics introduces randomness, different outcomes in each iteration. The cycle isn't perfect repetition, it's variation on a theme. Each time through, quantum events unfold differently. Different stars form, different planets coalesce, different life evolves, different civilizations rise and fall. Different individuals exist, make different choices, live different lives. You've lived this before. Not exactly this life. The quantum randomness ensures variation, but something close. And you'll live it again with variations in the next cycle. And again, and again. Eternally recurring. Never quite the same, but always fundamentally similar. Every possible variation that quantum mechanics allows will eventually occur, has already occurred, is occurring now in the cycle. This is Nietzsche's eternal recurrence, but physicalized. Not metaphor or thought experiment, actual cosmic structure. The universe cycles, and you cycle with it, living infinite variations on your essential existence, powerless to break the loop because the loop is all there is. Time doesn't extend infinitely forward into heat death. It curves back, creating a closed loop, and you're trapped in it forever. Can you bear that thought? That you'll experience versions of this life, this moment, this realization, infinitely many times? That there's no escape, no final ending, no relief of oblivion? That you're cosmically recurring, dancing the same dance with variations forever? Or perhaps it's liberating. If you'll live infinite variations, then every possibility will occur. Every version of your life where you make different choices, pursue different paths, experience different outcomes, all of them will happen, are happening, have happened, in different cycles. You're not limited to this single trajectory. You're the sum of all possible trajectories across all cycles, experiencing everything that quantum mechanics allows. The universe isn't dying. It's recycling, and you're part of that eternal recycling, experiencing it from infinite perspectives, living infinite lives, exploring infinite variations on the theme of your existence. The Big Bang and Big Crunch are the same event viewed from different temporal directions, and you're caught in the loop they create, cycling forever. But even this might not exhaust the strangeness, because we've been assuming there's one universe, one cycle, one loop. But quantum mechanics suggests otherwise. Every quantum event branches the universe into multiple versions. If the universe cycles, those branches cycle too, creating a tree of cycles, each branch experiencing its own eternal recurrence, all of them coexisting in the vast space of quantum possibilities. You're not in one cycle. You're in infinitely many, all branching from quantum events, all looping back on themselves, creating an infinite tree of eternal recurrences. The multiverse isn't separate universes. It's separate cycles, all stemming from the same origin point, all returning to that origin, creating loops upon loops upon loops, a cosmic fractal of recurring time. And somewhere in that infinite branching fractal, there's a version of you who understands this completely. A version who's figured out the mathematics, seen the pattern, grasped the structure. A version who knows, with certainty, that reality is a self-referential loop of quantum branches cycling eternally through the same phase space, varying infinitely within finite possibilities. But you're not that version. You're this version, reading these words, feeling the vertigo of cosmic knowledge, uncertain whether any of this is true or merely speculative, unable to verify because verification requires a perspective you don't have. And that might be the ultimate realization. Whatever the truth is, block universe or many worlds, cyclic, eternally recurring or collapsing toward oblivion, simulated or mathematical or self-causing through quantum loops. Whatever reality's fundamental nature, you can't verify it from inside. You're embedded, limited, finite in knowledge, even if infinite in branching or cycling. The truth exists, but it might be forever beyond your reach. Not because you're too primitive or because science hasn't advanced far enough. Because the truth might be structurally inaccessible from any embedded perspective. You'd need to be outside the universe to understand the universe. But being outside the universe means you're not part of what you're trying to understand. The ultimate truth requires a view from nowhere, but nowhere doesn't exist. Every observation is from somewhere, and that limitation might be insurmountable. So you're left with theories, models, frameworks that approximately describe what you observe, but never capture the full truth. The map is not the territory, and you have no access to the territory except through maps. Reality remains veiled, partially revealed through observation and mathematics, but never fully exposed. And yet, you keep trying. You keep building better theories, making more precise measurements, pushing deeper into the foundations. Not because you'll necessarily succeed, success might be impossible, but because the quest itself is what consciousness does. You're the universe trying to understand itself, and that trying might be more significant than any answer you could find, because the answer, if it comes, might be disappointing. The universe might be simple at its core, quantum mechanics plus boundary conditions, everything else following inevitably. Or it might be hopelessly complex, infinite branching, cyclic recurrence, higher dimensions, holographic projection, simulated layers, mathematical structures, all of it true simultaneously in ways that defy unified description. Either way, the mystery doesn't fully resolve. Simple answers raise questions about why simplicity. Complex answers raise questions about why that particular complexity. You can always ask another why, push deeper, demand further explanation. The chain of whys might terminate in brute facts, or might extend infinitely. But either way, complete satisfaction eludes you. Perhaps that's appropriate. Perhaps reality should be mysterious. A universe fully understood might be a universe drained of wonder, and wonder might be more valuable than knowledge. The sense of standing before something vast and incomprehensible, something that exceeds your grasp but invites your exploration. That might be the experience the universe exists to provide. Not exists to provide, because that implies purpose and design, but provides nonetheless, accidentally, as a byproduct of consciousness evolving in a complex cosmos. You're here, facing the mystery, experiencing awe and terror and fascination, and that experience might be the point, even if there's no intentional point, even if it's all cosmic accident. Look up at the night sky one more time. Those stars you see are photons completing journeys that began years or centuries ago. Some of those stars might already be dead, their light still traveling toward you, but the source extinguished. You're seeing ghosts, echoes, the universe's past displayed across the present sky, and if the universe is cycling, if eternal recurrence is real, then those stars have died, and been reborn countless times. The photons reaching your eyes now might be from the previous cycle, leaked through the singularity, carrying information from an earlier iteration of this same cosmic story. Or if many worlds is correct, then for every star you see, there are branches where it never formed, where quantum fluctuations produce different outcomes, where the galaxy has entirely different structure. All those branches exist, all those variations, all equally real, all coexisting in the vast Hilbert space of quantum possibility. Or, if we're simulated, then those stars are rendered photons, computed on demand, pixel-perfect replicas of what real stars would look like if the simulation were running on actual physics, rather than approximate algorithms optimized for efficiency. Or if we're collapsing toward the big crunch, then those stars are blue-shifted photons from objects rushing toward you, toward everyone, toward the central point of collapse, but experienced backward through time as red-shifted photons from objects receding. You don't know which interpretation is correct. You might never know, but the stars are there, in your experience, whether they're real or simulated or memory or prophecy, and your experience of them, the awe they inspire, the questions they raise, the sense of cosmic vastness they convey, that experience is real, whatever its underlying nature. This is what remains after all the theories, all the speculation, all the existential vertigo. Experience itself. You exist. You are conscious. You perceive a universe around you. That perception might be accurate or illusory, direct or mediated, but it's undeniable. Cogito ergo sum. I think, therefore I am. That remains, even if everything else becomes uncertain. And if you exist, if consciousness is real, then the universe has produced something remarkable. Something that can ask how reality came to exist, can contemplate its own nature, can experience awe and wonder and terror at the cosmic mystery. Stars are impressive. Fusion reactors powered by gravity, burning for billions of years. But they're not aware. They don't wonder. They don't question. You do. That makes you more extraordinary than stars, in a sense. Rarer, certainly. There might be more stars than observers in the universe. More complex. Consciousness is orders of magnitude more intricate than nuclear fusion. More improbable. The precise conditions necessary for consciousness are narrower than those for stars. And yet, here you are. Conscious, questioning, experiencing. The universe has been playing dice with quantum randomness for billions of years. And eventually, some of those dice rolls produced you. Or the future reached back and constrained the past to produce you. Or you're cycling eternally through infinite variations. Or you're branching across infinite quantum possibilities. Or you're simulated. Or you're mathematics. Or you're something stranger that we lack concepts to describe. Whatever you are, however you came to be, the fact remains. You exist. And your existence, the existence of consciousness anywhere in the cosmos, is the universe's greatest mystery and its greatest achievement. Not because it was intended, not because there's purpose, but because consciousness is complexity's pinnacle, information's highest organization, the universe's way of experiencing itself. You are that experience happening right now. You're the universe in this particular configuration, in this particular place and time, aware of itself, questioning itself, trying to understand how it came to be. And that trying, that questioning, that awareness, perhaps that's what all of this was building toward. Not teleologically, not by design, but inevitably. As a natural consequence of physical law operating on quantum fluctuations over billions of years, the Big Bang, whether beginning or end or both or neither, led to you through expansion, inflation, nucleosynthesis, structure formation, star birth and death, planet formation, chemical evolution, biological evolution, neural complexity, consciousness, civilization, science, philosophy, existential questioning. The chain is unbroken from the first moment to this moment. You're the culmination of that chain, standing at its leading edge, looking back at the history that produced you and forward to the mystery that awaits. And what awaits? More mystery, deeper questions, further horizons receding as you approach them. The universe doesn't offer final answers because final answers might not exist. Or they exist but remain forever inaccessible. Or they're accessible but disappointing. Or they're satisfying but raise new questions equally profound. You'll never escape the mystery. It's built into the structure of embedded observation, of consciousness trying to understand the cosmos that contains it. The container is always larger than the contained, and you can't step outside to see the whole. You're part of what you're trying to understand, and that circularity might be essential, unavoidable, the price of consciousness. But the quest continues. Even knowing you might never find final answers, you continue searching. Because searching is what conscious beings do. Because wonder demands exploration. Because the mystery is so compelling that you can't look away, can't stop asking, can't accept ignorance even when knowledge brings more questions than answers. This is your cosmic situation, embedded in mystery, conscious of the mystery, driven to explore it, despite knowing full understanding might be impossible. And that situation is universal. Every conscious being anywhere, anytime, faces the same predicament. The details differ. Different biologies, different planets, different civilizations, different levels of knowledge. But the fundamental condition is the same. Consciousness embedded in cosmos, trying to understand, never quite succeeding completely. If there are other conscious beings out there, and in an infinite universe or infinite multiverse, there almost certainly are. They're experiencing their own version of this, looking up at their sky, wondering how it all came to be, building theories and models and frameworks, pushing against the limits of knowledge, experiencing the same awe and terror and fascination that you feel. You're not alone in your questioning. Even if you're alone in this particular moment, across space and time and possibility space and quantum branches, other minds are asking the same questions, feeling the same wonder, confronting the same mystery. You're part of a cosmic community of questioners, most of whom you'll never meet, never communicate with, never know. But they're there, asking, wondering, exploring, and maybe that's the answer. Not an answer to how reality came to exist, but an answer to what consciousness is for. It's for this, for questioning, for wondering, for pushing against the boundaries of the unknown. Not because there's a goal to reach or a final destination to arrive at. Because the journey itself is the purpose, or as close to purpose as an accidental universe provides. You're on that journey now. You've traveled from the Big Bang through cosmic history, through existential crisis, to this moment of realization. And the journey continues, because questions remain, because mystery deepens, because every answer opens new vistas of ignorance. The universe came to exist, somehow. Maybe through quantum tunneling from nothing, maybe through eternal recurrence, maybe through self-causation across time, Maybe through mathematical necessity. Maybe through simulation. Maybe through something we haven't imagined. The question remains open, might always remain open, but you exist to ask it. And that might be all that matters in the end. Not the answer, but the asking. Not solving the mystery, but experiencing it. Not explaining reality, but being reality, conscious and questioning and aware. This is the final realization. You are the universe becoming conscious of its own mystery. You are existence questioning existence. You are reality experiencing itself, asking how it came to be. Knowing the answer might be forever beyond reach, but asking anyway, because asking is what consciousness does. The Big Bang happened, or didn't, or is happening now in reverse as you collapse toward oblivion, or is cycling eternally, recycling you through infinite variations, or is one branch among infinite branches, all real, all coexisting, or is the initialization of a simulation, or is mathematical truth instantiating necessarily, or is something stranger still? You don't know. You might never know. But you're here, experiencing it, questioning it, wondering about it. And that experience, that consciousness confronting cosmic mystery, might be reality's deepest layer, deeper than quantum fields, than space-time geometry, than mathematical structure. The fact that there's something it's like to be you, that subjective experience exists, that awareness is woven into the cosmos, that might be the ultimate mystery, more profound than the origin of everything, because the origin of everything led to you, to consciousness, to this moment of questioning. And if consciousness is what the universe has been building toward, not intentionally, but inevitably, then perhaps the question of origin is really a question about consciousness. Why is there consciousness rather than unconscious process? Why does the universe experience itself rather than merely existing? And maybe those questions are the same question. Maybe existence and experience are inseparable. Maybe consciousness is fundamental, and the universe exists because experience requires something to experience. Maybe reality is what experience feels like from the inside. And asking how reality began is asking how experience began. And those might be the same question asked different ways. The mystery deepens rather than resolves. Every answer you've encountered has raised new questions. And now, at the end, you're left with the biggest question of all. Not how reality came to exist, but why there's anything to experience reality. Why consciousness? Why awareness? Why you? The cosmos doesn't answer. It continues expanding or contracting, branching or cycling, computing or instantiating, indifferent to your questions or structured by them, you can't tell which. The stars shine. Galaxies rotate. Space stretches. Time flows or doesn't flow. Forward or backward or not at all. And you experience it. Briefly, mysteriously, impossibly. This is what you're left with. The raw fact of experience. Inexplicable. Undeniable. Everything else, theories, models, explanations, is constructed on that foundation. But the foundation itself remains mysterious. Why there's experience rather than none might be the one question that can never be answered, because any answer presupposes experience to understand it. So you're trapped in a strange loop. Experience trying to explain experience. Consciousness examining consciousness. Reality questioning reality. The loop is inescapable because you can't step outside it. You're part of what you're examining, using consciousness to study consciousness, employing thought to understand thought. And yet, Within that loop, you've discovered so much. The age of the universe, the structure of space-time, the quantum nature of reality, the expansion rate, the composition of matter, the formation of galaxies, the evolution of life, the mechanics of consciousness. You've mapped the territory from within the territory, drawn the picture from inside the frame. The achievement is staggering when you stop to consider it. Conscious beings on one planet, around one star in one galaxy, have figured out the cosmos's basic architecture, traced its history back to the first microsecond, predicted its future trillions of years hence. You've split atoms and detected gravitational waves and imaged black holes and measured the universe's geometry. You've done this with neurons and mathematics, observation and reason, imagination and discipline. And still the mystery remains. Deeper than before, not shallower. More profound for being partially illuminated, not less. You know so much more than your ancestors, and yet you're more aware of how much you don't know. The circle of knowledge has expanded, but so has the circumference of ignorance surrounding it. This might continue forever, each answer revealing new questions, each discovery opening new mysteries, the horizon of knowledge receding as you approach, always beyond reach, always inviting further exploration. You might be on an infinite quest, chasing understanding that can never be complete. Or perhaps, someday, someone will find the final answer. The theory of everything, explaining how reality came to exist, why it has the structure it does, what consciousness is, how it all fits together. And that answer will be satisfying, complete, leaving no questions unanswered. The mystery will be solved, the quest completed, the cosmic puzzle assembled. Do you want that? Or would it be disappointing? A universe fully explained might be a universe drained of magic. The mystery, frustrating as it is, might be what makes reality worth experiencing. Take it away, and what's left? Facts without wonder, knowledge without awe, understanding without the delicious vertigo of confronting the unknown. Perhaps the universe is structured to be eternally mysterious, forever beyond complete comprehension, always offering new depths to explore. Perhaps that's not a bug, but a feature. Perhaps reality should exceed our grasp, should maintain an element of irreducible strangeness, should remain fundamentally wonderful in both senses, full of wonders and provoking wonder. And you're here to experience that wonder. That's your role, your function, your cosmic position. Not to solve the mystery. That might be impossible. But to experience it, to engage with it, to let it expand your mind beyond comfortable boundaries into terrifying and exhilarating territories of thought. This is what the journey has been. An expansion of your conceptual space, a stretching of your imagination, a confrontation with ideas that break intuition and rebuild it larger. You started with a simple question. How did reality come to exist? And you've descended through layers of strange answers, each stranger than the last, until arriving here, at the realization that the question might be unanswerable but remains worth asking. Because asking changes you. Exploring the mystery transforms you. Confronting cosmic horror and cosmic awe expands you. You're not the same person who began this journey. Your mind has been stretched by concepts too large for it, and it won't snap back to its original shape. You've been changed by the encounter with ultimate questions, and perhaps that's the point. Not to find answers, but to be transformed by questions. Not to solve mysteries, but to be expanded by them. Not to explain reality, but to be awed by it. The universe exists, somehow, and you exist within it, somehow, and the encounter between your consciousness and the cosmos's mystery creates something valuable. Even if that value isn't instrumental, doesn't lead anywhere, doesn't accomplish anything beyond itself, the value is intrinsic. The experience itself is the value. You've experienced wonder, terror, awe, confusion, fascination, vertigo. You've felt your mind bend under the weight of cosmic knowledge. You've experienced the strange sensation of understanding and not understanding simultaneously, grasping concepts intellectually while finding them experientially impossible. This is what it means to be conscious in a cosmos, to experience the gap between what you can calculate and what you can comprehend, between mathematical truth and experiential reality, between knowing and understanding. That gap might never close. The experience of it might be what consciousness is for. Now comes the final moment, the last realization, the thought that will haunt you as you return to everyday life, carrying this cosmic knowledge like a weight you can't put down. If the universe is infinite, spatially infinite, with infinite matter, infinite planets, infinite possibilities, then somewhere, right now, another version of you exists. Not in a quantum branch, not in another cycle. In this universe, this moment, this timeline, somewhere so far away that light from there will never reach here, beyond the cosmic horizon, causally disconnected but physically real. That other you is reading these exact words, or words almost identical, with minor variations from quantum randomness. They're having the same thoughts, experiencing the same realizations, feeling the same vertigo. They're you in every meaningful sense. Same history, same memories, same consciousness, just instantiated in different matter in a different location. In an infinite universe, this must be true. Any finite configuration that can occur will occur infinitely many times. You're a finite configuration. There are only so many ways atoms can be arranged to make a human brain with your specific neural patterns. In an infinite universe, that arrangement repeats. Not just twice, not just 1 billion times, infinitely many times. Right now, infinite versions of you are experiencing this exact moment. Infinite versions just finished reading these words. Infinite versions are about to read them. Infinite versions made slightly different choices and are reading something else, or not reading at all, or never learned to read, or never existed because quantum randomness produced different outcomes on their distant planets. Every possible version of you that's consistent with the laws of physics exists somewhere in the infinite universe. The you who became a musician instead of your actual career. The you who never met your partner. The you who died young. The you who achieved great fame. The you who lived in obscurity. The you who made every right choice and every wrong choice. All of them exist, scattered across infinity. Each believing they're the only one, each experiencing their life as unique. You're not unique. You're repeated infinitely, not in a multiverse, in this universe, right now, if space extends infinitely. Your life, your consciousness, your exact mental state at this moment, copied infinitely throughout infinite space, each copy unaware of the others, each living the same life in different locations. Does this comfort you or horrify you? You're not alone. Infinite copies of you exist. But you're also not special. You're one of infinite duplicates, distinguishable only by spatial location, not by any intrinsic property. Your uniqueness, your individuality, your sense of being a particular person, All of it is illusion if you're repeated infinitely. And if the universe is not just infinite but eternal, through cycles or branches, then you're not just repeated in space, but in time and possibility space. Infinite versions across infinite space, in infinite branches, in infinite cycles. The number of yous approaches a higher order of infinity, so vast that the concept loses meaning, collapsing into something beyond counting, beyond comparison, beyond comprehension. You are legion. You are singular. Both are true, depending on perspective. From your embedded viewpoint, you're one person, unique, experiencing this moment uniquely. From the cosmic viewpoint, you're a pattern that repeats infinitely, a configuration that instantiates whenever conditions allow, a process that runs wherever physics permits. Which perspective is correct? Both. Neither. The question assumes a privileged viewpoint that doesn't exist. You're embedded, experiencing from inside, unable to access the cosmic view. And the cosmic view, if you could access it, wouldn't invalidate your embedded experience. Both are real, both matter, both are true in their own context. This is the final paradox. You're simultaneously unique and repeated, singular and infinite, individual and pattern. The contradiction is resolved not by choosing one side, but by accepting both, holding them in tension, recognizing that reality is large enough to contain contradictions that would be impossible in simpler systems. And now you have to live with this knowledge. You have to return to everyday life, eating, working, sleeping, loving, dying, carrying the weight of cosmic mystery, knowing what you now know, unable to unknow it. The universe came to exist somehow, and you're part of that somehow. Asking about it, wondering about it, experiencing it from inside. How did reality come to exist? The question remains open. The answer, if there is one, remains hidden, veiled, perhaps forever beyond reach. But the asking continues, because you're here, conscious, questioning, unable to stop wondering even when answers don't come. And somewhere, across infinite space, another you is finishing this same thought, experiencing this same realization, feeling this same weight of cosmic knowledge settling onto their consciousness. They're you, you're them, both singular and infinite, unique and repeated, alone and accompanied by infinite copies. The mystery endures. Reality continues its expansion or contraction, its branching or cycling, indifferent to your questions or shaped by them, you can't tell which. The stars shine their ancient light into the void. Space stretches between them. Time flows or doesn't flow, and you experience it all, briefly, mysteriously, impossibly, asking the question that has no answer but demands to be asked anyway. How did reality come to exist? Look up. The answer, or the eternal absence of answer, is written in the stars, encrypted in the cosmic microwave background, encoded in the quantum foam, hidden in the structure of consciousness itself. You'll spend your life searching for it, and you'll never find it completely. But the search itself is what it means to be human, to be conscious, to be a part of reality asking about reality. This is your inheritance and your burden, cosmic consciousness, aware of the mystery, unable to solve it, unable to stop trying. Carry it well. Ask the questions. Experience the wonder. Live briefly in the vast cosmic story, knowing your part is small but meaning something nonetheless. at least to you, at least for now, at least in this particular instantiation of the infinite pattern that you are. The universe existed before you and will exist after you. But right now, in this moment, you're here, experiencing it, questioning it, being it. And that might be all the answer you get, all the answer there is, all the answer that matters when the cosmic mystery finally reveals its deepest truth. Not an explanation, but an experience. Not knowledge, but wonder. Not understanding, but awe. You are that awe, embodied, conscious, temporary, asking how you came to be, knowing you might never know, asking anyway. Because asking is what consciousness does in a cosmos that produced it for no reason except that physics allows, chemistry enables, biology evolves, consciousness emerges, and questions follow inevitably from awareness. How did reality come to exist? Perhaps it's still coming to exist right now, through you, through your asking, through consciousness observing and constraining and collapsing quantum possibilities into definite outcomes. Perhaps the universe is birthing itself continuously, and you're part of that birth, midwifing reality into existence through your observations, your measurements, your conscious experiences. Perhaps that's the answer you've been seeking. Reality comes to exist through being experienced. Consciousness doesn't observe reality. Consciousness is how reality exists. And asking how reality came to exist is asking how experience came to exist. And those are the same question. And the answer is that experience doesn't come from anywhere else. It's fundamental, basic, the ground of everything, and all of physics and cosmology and existence flows from it. Or perhaps not. Perhaps consciousness is epiphenomenal, meaningless, a cosmic accident signifying nothing, and reality exists independently. And all your questioning is sound and fury from a brief pattern in one corner of an indifferent universe. You don't know. You can't know. The mystery remains, deeper than ever, more profound for your exploration, more mysterious for being partially revealed. And that mystery, that fundamental unknowing at the heart of existence, might be the only answer you ever get. The only answer there is, the only answer that could possibly suffice for something as strange as consciousness embedded in cosmos, asking how it all came to be. The answer is, mysteriously. Reality came to exist mysteriously. And you're here to experience that mystery, briefly, impossibly, magnificently, before dissolving back into whatever nothingness or everythingness you emerged from, leaving the mystery unsolved for whoever comes next, asking the same questions, experiencing the same wonder, confronting the same cosmic mystery that has no end and no answer and no escape. How did reality come to exist? The question echoes through eternity, unanswered, unanswerable, essential, and somewhere, somewhen, some other consciousness is asking it right now, experiencing the same vertigo, feeling the same awe, carrying the same burden of cosmic awareness. That consciousness might be you, in another branch, another cycle, another location, another moment of the eternal now. You asking yourself how you came to be, forever, across infinite instantiations, never finding the answer, but never stopping the search. Because the search is what you are, what consciousness is, what it means to be aware in a cosmos that produced awareness for reasons unknown and perhaps unknowable. This is the end, which is also the beginning, which might be the same moment viewed from different temporal directions. The Big Bang might be happening right now. Creation might be continuous. Existence might be eternal, or it might all collapse in the next instant, leaving nothing but the quantum void, until another fluctuation, another universe, another consciousness asking how it came to be, and the cycle continues, or doesn't, or never started, or always was. The mystery endures. Reality persists in existing mysteriously. And you're here, now, wondering about it, experiencing it, being it. That experience is the only certainty in an uncertain cosmos. Cogito ergo sum. I experience, therefore something exists to have the experience. Beyond that, everything becomes uncertain, mysterious, wonderful, and, perhaps, wonderful is enough. You've traveled 13.8 billion years in a single sitting. You've descended from the Big Bang through cosmic history, through quantum foam and many worlds, through time loops and simulations, through existential crisis and cosmic horror, arriving here, at this moment, forever changed by what you've encountered. You can't go back to who you were before. The questions have infected you. The mystery has taken root in your consciousness. You'll look at the night sky differently now. You'll experience time differently. You'll think about your existence differently. The cosmic perspective has been burned into your awareness, and it will never fully fade. This is not a conclusion. You haven't found the answer to how reality came to exist. You've discovered something more valuable and more disturbing. The question is deeper than anyone imagined, and the answer, if it exists, might be forever beyond human reach. But that doesn't make the journey worthless. You've seen things most people never contemplate. You've held impossible ideas in your mind. Block universes and quantum immortality, cyclic time and infinite duplicates, consciousness as fundamental and reality as mathematics. Your mind has been stretched by concepts too large for it, and it won't return to its original shape. This expansion is permanent. You've touched the cosmic mystery directly, felt its weight, experienced the vertigo of standing at the boundary between knowledge and ignorance. And that experience, that direct confrontation with ultimate questions, changes you at a fundamental level. You now know that the universe is stranger than you were taught, stranger than most people believe, stranger, perhaps, than it's possible to believe while still functioning in everyday life. The comfortable narratives that the universe began in an explosion, that time flows forward, that you're a singular entity making free choices. All of them have been revealed as approximations at best, useful fictions at worst. But you also know something else, that strangeness is magnificent. The universe's refusal to be simple, to be easily understood, to fit into human-sized concepts, that's not a failure of the universe. It's a testament to reality's richness, its depth, its fundamental mysteriousness. A universe you could fully understand would be a smaller, lesser universe. The mystery is what makes it sublime, and you're part of that sublime mystery. Not separate from it, observing from outside. You are the universe observing itself, questioning itself, experiencing itself. Your consciousness is reality's way of knowing it exists, and that makes you, brief, finite, temporary as you are, an essential part of the cosmic story. Think about what you've learned. You've traced existence from potentially nothing to definitely something through quantum tunneling or eternal recurrence or self-causation or mathematical necessity. You've seen how the early universe evolved from plasma to atoms, to stars, to galaxies, to planets, to life, to consciousness. You've explored the possibility that time is illusion, that you're fragmented across infinite branches, that reality might be simulation or mathematics or something stranger still. Every answer raised new questions. Every solution revealed deeper problems. The horizon of knowledge receded as you approached it. And yet, you learned, you expanded, you grew. The journey wasn't futile. It was transformative. Now comes the hard part. Living with this knowledge. Returning to your life, carrying these impossible ideas, unable to share them fully with people who haven't made this journey. You'll try to explain, time might not be real. I might exist infinitely across quantum branches. The universe could be collapsing right now and we'd never know. And people will nod politely, not understanding the weight, not feeling the vertigo, not grasping how these ideas fundamentally alter everything. That's okay. Some knowledge is solitary. Some realizations can only be reached through personal exploration. You can point others toward the mystery, but you can't make them feel its full weight. They have to carry it themselves, but you can do something else. You can continue questioning. You can refuse to accept easy answers or comfortable narratives. You can maintain the sense of wonder and terror that comes from confronting ultimate mysteries. You can live as someone who knows that reality is stranger than it appears, deeper than it seems, more mysterious than it's possible to articulate. This isn't a call to abandon everyday life for constant philosophical contemplation. Bills still need paying. Relationships still need tending. Work still needs doing. But you can do all of it while carrying the cosmic perspective, while remembering that you're a temporary arrangement of stardust asking how it came to be, while staying open to the possibility that everything you think you know might be wrong. The universe doesn't owe you answers. It doesn't care whether you understand it. But it has given you this: consciousness, awareness, the ability to ask questions, and to experience wonder at your own existence. That's a gift, even if it's an accidental one, even if gift implies an intentionality that doesn't exist. What will you do with it? Will you sink back into comfortable ignorance, pretending the mystery doesn't exist? Or will you carry this knowledge forward? Let it inform your choices. Allow it to deepen your appreciation for the strangeness and beauty of existence. The choice, if it is a choice, if free will exists at all, is yours. But having come this far, having traveled this deep into the mystery, it seems unlikely you'll be able to forget what you've learned. The cosmic perspective is sticky. It clings to consciousness. It changes how you see everything. Look around you right now. The objects near you, furniture, walls, devices, are made of atoms forged in stellar furnaces. The air you're breathing contains oxygen produced by ancient cyanobacteria. The neurons firing in your brain as you process these words are following patterns shaped by millions of years of evolution. You're not separate from the cosmos. You're a particularly interesting way for the cosmos to be arranged. And this arrangement, this pattern that is you, is asking the biggest question possible. How did reality come to exist? You're not likely to solve it. Neither am I. Neither is any individual human, perhaps. But collectively, across generations, we're pushing deeper. Each generation inherits the questions and the partial answers from the previous one, adds their own observations and insights, and passes a larger body of knowledge forward. You're part of that chain, not just by reading these words, but by carrying the questions forward, by refusing to stop wondering, by maintaining the sense that reality's ultimate nature remains hidden and deserving of exploration. Maybe your children or their children will live to see quantum gravity finally unified. Maybe they'll observe other universes or detect the signatures of previous cosmic cycles. Maybe they'll find evidence that settles the question of whether we're simulated, whether time is fundamental, whether consciousness is basic to reality. Or maybe the mystery will deepen. Maybe every answer will raise two new questions. Maybe the horizon will forever recede. Maybe that's how it should be, how it must be, how it always will be. But the quest continues. Consciousness continues asking. The universe continues revealing itself, layer by layer, mystery behind mystery, each revelation more strange and wonderful than the last. And you're here for it. You're present at this particular moment in cosmic history, when humans know more than ever before, but are more aware than ever of how much we don't know. You're living in the age of cosmology, of quantum mechanics, of computers and telescopes that can peer back to the universe's infancy. You're witnessing humanity's awkward adolescence as a species, old enough to ask profound questions, young enough to lack most of the answers. What an extraordinary time to be conscious. What a remarkable moment to exist. The universe has been evolving for billions of years, and it has produced you, here, now, capable of contemplating its origin and your place within it. Don't waste this. Don't let the weight of cosmic knowledge crush you into nihilism or apathy. Instead, let it inspire you. Let it remind you that every moment is precious because it's temporary. Let it help you see beauty in the everyday, because the everyday is made of the same stuff as stars, governed by the same laws that produced galaxies, participating in the same cosmic story that began, somehow, at the beginning of time. How did reality come to exist? The question remains open. The mystery endures. And that's okay. That might even be perfect. Because the question keeps you searching, keeps you wondering, keeps you engaged with the fundamental strangeness of existence itself. So carry this question forward. Let it haunt you in the best way. Let it make you curious, humble, awestruck. Let it remind you that you're part of something vastly larger than yourself, something that began before you and will continue after you, something strange and magnificent and ultimately mysterious. The universe may have no end. The cycles may continue eternally. The branches may proliferate infinitely. Time may loop back on itself, bringing everything around again in endless recurrence. And somewhere in that vastness, across infinite space or infinite branches or infinite cycles, another version of you is experiencing this exact moment, feeling this exact sense of wonder and terror, asking this exact question about how reality came to exist. That version of you will never find the complete answer, just as you won't. But they'll keep asking, as you will. Because asking is what consciousness does. Because wonder is what awareness feels when confronting mystery. Because the question itself is the answer to what it means to be alive, to be conscious, to be a brief flickering of awareness in a vast and ancient cosmos. Keep asking, keep wondering, keep experiencing the strange, impossible, magnificent fact of your own existence. The universe came to exist somehow, and so did you. And those two mysteries might be the same mystery viewed from different angles. You are reality experiencing itself. You are the cosmos asking how it came to be. You are the question and the questioner, the mystery and the one who experiences the mystery, the universe and the awareness of the universe. And perhaps, in some profound sense, That's what it means for reality to exist at all, to be aware of itself, to question itself, to experience the strange, recursive loop of existence contemplating existence. The Big Bang happened, or didn't, or is happening right now, continuously, eternally, through you, through your consciousness, through your questions and your wonder, and your refusal to accept easy answers to impossible questions. How did reality come to exist? It's still coming to exist, right now, through you, through your asking, through consciousness emerging from complexity, emerging from chemistry, emerging from physics, emerging from something that might have been nothing, or might have been everything, or might have been something else entirely, that we lack words to describe. The story isn't finished. It's never finished. Because the ending and the beginning might be the same moment. Because time might be circular. Because you might be trapped in eternal recurrence, experiencing this realization infinitely, many times across infinite iterations. Or perhaps this is the first time, the only time, your one chance to experience wonder at cosmic mystery, to feel the weight of ultimate questions, to carry the knowledge that you're temporary, but the mystery is eternal. Either way, you're here now. Consciousness in cosmos, awareness in existence, questions in the face of mystery, and that remarkable, impossible, magnificent fact might be the closest thing to an answer you'll ever find. The universe may have no end, but maybe, just maybe, neither do you. Now go. Live. Question. Wonder. Experience. And remember, somewhere in the vast cosmic mystery, across infinite space or branches or cycles, countless versions of reality are asking how they came to exist. And in every one of them, consciousness is reaching toward understanding it may never achieve but cannot stop pursuing. That reaching, that questioning, that endless wonder, that's not a bug in the cosmic program. That's the entire point.